Hello and welcome to the complete GraphQL guide. In this guide, I'll explain GraphQL to someone who has never used it before, and we will build a full stack expense tracker app while learning and implementing these GraphQL concepts. This course is meant for beginners, but intermediate and advanced concepts are also included, such as authentication, session stores, cron jobs, and deployment. We will not just learn how to build a GraphQL API, but we will also learn some best practices, such as why and how to merge your type defs and resolvers to keep your codebase clean and maintainable. And at some point in your developer journey, you'll be using GraphQL. And if you want to get started, this might be the course that you're looking for. Now, we'll talk about the course outline in a second, but first let me give you a quick showcase of our application. So this is the application that we'll have at the end of the day. Now we are in the login page. We don't have an account. Let's go ahead and sign up. I'll say my full name will be Jane Doe, and then this will be my username, and then I'll just put a password. Let's select our gender, and then we'll just try to sign up. We have a loading state. Once it is completed, we are in the home page where we could add some transactions. Now let's take a look at in our database. We didn't have anything, but let's refresh. We should get that user as well as a session that says this user has just been authenticated. Let's take a look at the users. Now we have the session, and let's see the user profile information. Here we can see user has been created. This is the username that we have passed. This is the name. This is the password that is being hashed, and then the profile pic, and then the gender. This profile picture has been created dynamically. And for this, we have added some logic in our database. Now let's try to add a transaction. Let's say we just got our salary, and then payment type was card. It is a saving, and let's put some amount, and then we'll say location was New York, and then we'll just put a date. Let's say we got it in the first day of the month, and let's select it and add the transaction. We had a loading state, and it says transaction created successfully and our UI updated. Let's try to add another one. I'll just say I paid my rent, which was type of expense, and then the amount will be, let's say, $2,000. Then we could select the date. I'll just say this will be the date, and for the location, this is optional. If you want to, we just skip that and don't put any value. Let's add the transaction. Here we go, transaction created, and it updates the UI both in the history and then in our chart. Let's add an investment. I'll just say Bitcoin for the sake of example, and then I'll put $500. Let's select the date. I just bought it last week, and then I bought it online. I'll say add the transaction. It should update UI accordingly. And if we hover over them, here we can see we have spent $2,000 for the expense, $500 for investment, and the rest of it for the saving. If we wanted to, we could update any of these transactions. Let's go and make the investment. Let's just try to update the amount. We'll say this will be 5,000, and let's say Bitcoin updated. And if we update the transaction, it should update it. Let's go into the home page. Here we can see this is the amount, and description has been updated. And if we try to delete one of them, it should both update history as well as our chart. And if we try to visit our database, now we should have some collection called transactions. Let's refresh, and we should be able to get two different transactions, which is this investment and then this saving that we have just added. Here we go, we have the transactions table or the collection, and these are the two documents that we have. And this application is completely responsive. Let's see. So these are the console logs that we have. Let's ignore them. But there we can see it just works fine and as expected. And in this application, we are using Apollo client, which allows us to have some caching and just optimize our performance. Let's go into the application, we'll just go into the network. Let's select the fetch XHR, and if we visit this transaction for the first time, that's going to send a request, but we cannot see that because this is the second time that we visit. Let's refresh this page. Okay, we have a couple of different network requests. Let's visit this one, then it should send another one. Here we can see we just fetched this transaction. But for the second time, if we visit that page, we are not going to have any network requests because this data has been cached. Here we can see the data is immediately here and we didn't have any network requests. So overall, this is going to be the application, and when we log out, it's going to take us back to the authentication page. And if we take a look at the sessions, we shouldn't have any documents. And that means that user just logged out. That's gonna be it for the app showcase. Now let's see the course outline and then we'll jump into the code. So this course consists of 4 major parts. In the first part of our course, we will build an entire GraphQL API with Node.js, Express, and Apollo server. We will learn fundamental concepts of GraphQL such as type defs, resolvers, queries, mutations, schema, etc. First, we will work with some hard-coded data to be able to learn basics. Then we will create a MongoDB database to be able to work with real data. And lastly, in this section, we will add the authentication system with Passport.js. Moving on to the next part, we will focus on the UI design with the help of Tailwind CSS. Also, we will learn how to add charts into our application. And again, in this part, we will work with hard-coded data for the sake of UI, and we will replace it with the actual data in the third part. And we don't want to waste any time by writing Tailwind CSS classes. That's why I'll provide you all the UI components where we'll copy and paste together and complete this part as fast as possible. You don't need to feel bad just because we copy and paste some code. There will not be any logic. It's pure CSS and we all know the basics. And the third part will be the most exciting part, where we connect our React application to the GraphQL API that we have built. So we will be able to authenticate from the React application and implement CRUD operations. And just before we end this section, we will learn how to add relations in GraphQL, which is a bit advanced concept. That's why we will learn it at the end. Finally, we will configure our backend to be ready for deployment, and then we will deploy it for free using Render Platform. This is gonna be it for the course outline, and if you get stuck any point in time, feel free to join our Discord server, and you can find the link in the description below. And lastly, I am trying to grow this channel by publishing full stack courses consistently. If you think it's worth it, consider subscribing. Thanks for watching, and let's get started. So before we start coding, let's try to understand what is GraphQL. And for this, we could head over to the GraphQL documentation. And let's see what they say. So they say GraphQL is a query language for APIs, and it is a runtime for fulfilling those queries with your existing data. Now this doesn't make too much sense for now. That's why I have created a couple of different diagrams that we could take a look. And before we get into the GraphQL, let's just try to remember the REST API architecture. Now in a REST API, we would have some kind of client. Let's say we have a React application, and then we would have our server. Let's say it is Express Node.js server, and then some kind of database, and let's say it is MongoDB. Then in our server, we would have different endpoints. Let's say we have one for users, which is going to fetch all of our users in our database. And then we could fetch a single user with their IDs. We could fetch all posts or just one post. And then depending on the endpoint, we would call some kind of function or controller and get the response back to the client. And client could send these requests, which is get, post, put, and delete. Now that was the REST API, and let's see the GraphQL. Now again, we will have a client application. Let's say it is React, and then we would have an Express Node.js server, GraphQL on top of it, and then some kind of database. Let's say it is MongoDB. And we would have only one endpoint, which is GraphQL. So we wouldn't have these different endpoints, but rather just once or just one. And then we will send some queries and mutations. And basically a query is a GET request where you just want to fetch some data without having any side effects. But mutation would be these other operations where we could create something, we could update something, or we could delete something, right? Or some resource. And yeah, that's gonna be it. And to be able to send these queries and mutations in the client, we'll be using Apollo client package or Apollo client tool to be able to send these queries and mutations. And that's gonna make a lot of sense once we start coding. And then just to show some examples of queries and mutations, I have some code examples. And for now, just don't see the resolver, but focus on the query. So we would create a query with this keyword and we would give it a name. So this could be anything, and I just called it as get transactions. Now we just say we want to fetch the transactions query, and for each transaction we would like to have these fields, which is underscore ID, description, payment type, and rest of this. And we would get a response back as the transactions array, and for each transaction we would have all these fields. So ID, description, payment type, and the rest of them. If we wanted to, we could just delete the, let's say, the amount, location, and date. If we don't add it into this object, then transactions will not have those fields. And this is possible with the help of GraphQL. You can't really do this in REST API. You just get every resource that is possible in an object. But instead, you could just eliminate some fields that you don't want to get. And for when we send this query, we need to have some kind of resolver in the backend so that we could run the logic and then fetch that data and send it back to the client. So here we said that this is the query name, and that is under the query in our resolver in the backend, right? This is the transactions and it matches exactly with this one. And we got some arguments, which we'll see that later in the video. And then we run our logic and just fetch the transactions and return it as a response. So that's going to be it for the queries. And then we could also send queries with arguments, right? So we just want to fetch one transaction and we just pass the transaction ID, and depending on that we run some resolvers in the backend and we send it as a response to the client. And here these are the fields that we'd like to fetch. And then we had the mutations. Again, it is mostly the same, where we just say we want to send a mutation, which is sign up, and we just call it with the inputs, which is the type of sign up input, where we have the username, name, password, and gender. Here I'll just zoom in a little bit, and we destructure that from the input, and depending on that we handle the errors and then the rest of the logic. And once we sign up the user, we just send a response back and we say we want to see the ID, name, and username, and that's going to be the response. Now this might not make too much sense for now, but I'm sure that will make once we get into the coding. Here I just put them so that we could see and just visualize it. And there is one last example. So here in the REST API, where we just want to fetch a user. So we would send a request, this ID, and then we would get a response back for this user, where we have the username, name, and then the bank account ID. If we want to fetch this bank account information, then we need to send another request to this endpoint. So API bank and then the bank account ID. And that's going to give us the bank accounts information. But now here, notice how we need to send two different requests just to get these data. But in a GraphQL, if we had relationships, we could do that only with one request. So we would say send an endpoint to this /GraphQL endpoint, where we just want to query this user data. So we're going to get the ID, username, name, and then we'll say we also want to get the bank account, and it's going to give us back as well. We don't need to send that another request. And if you take a look at the documentation, you could see the exact same thing. So that they say get many resources in a single request, and we'll see that later in the video as well. So that's gonna be it for the kind of diagrams, and I think we're ready to start with coding. So I have created an empty folder, and now I'd like to create two more folders, one for the backend and then the other one will be for the front end. Now we would like to create a package.json in the root, let's say npm init-y, and this package.json will contain all of our dependencies for the backend and some scripts that is going to be important for the deployment. For now, let's just say CLS, and we will install a couple of packages. Now the list will be a bit long, so I'll just say copy paste .md file, which you can find from the GitHub repo, and I'll just paste the packages that we'll install, and you could grab them from the repo as well. So let's say this is going to be bash script, where you could copy and paste it. Now so this list is a bit long, but I'll explain each of them as we use. So don't worry about that for now. Just copy it, paste it into the root, and press enter. That's going to install all of our packages, and it's going to give us a node modules folder. So now they have been installed, and I just want to paste a couple of nodes into this file, and let's see, that's going to be about the packages. So we have the GraphQL package that we just installed, and then the Apollo package. Now this GraphQL package is the core GraphQL implementation in JavaScript. So it provides the functionality to define GraphQL schemas, and we're going to get that what that means. And it allows you to parse and validate GraphQL queries, execute queries against the schema, and format responses. So this GraphQL is not tied to any specific server or client framework. It is a standalone library that can be used in various JavaScript environments. Okay, you could just have it as a node. That's why I'm just providing it. And then the Apollo server package, this is the part of the Apollo ecosystem, and it is used for building GraphQL servers in Node.js. And it provides tools and utilities to create and manage GraphQL schemas, handle incoming GraphQL requests, execute queries, and send responses. So overall, it is just simplifies the process of creating and maintaining GraphQL servers in Node.js environments. Okay, with that long explanation, let's try to see and understand what we'll be doing. Now inside the backend, we would like to create a file called index.js, and inside the package.json, we would like to create a script. Let's say start, and we'll say node. We would like to go into the backend folder and then call this index.js file, right? So we need to go into the backend folder is because this package.json file will be run in the root, and yeah, that's the reason. And then you'd like to have another script, let's say dev and nodemon backend index.js, but we don't have the nodemon package. Let's try to install it. I'll say npm first. Let's clear the console. Okay, npm install nodemon -- save dev, and that's gonna install it as a dev dependency. And let's save this file. I think it is not gonna crash. Let's see. Okay, because when you are when you are installing a package, don't try to update this file. Just wait for it to be installed and then try to update it. That's why I said I hope it's not gonna crash, and it didn't crash. Okay, so now let's go ahead and try to see the documentation. I'll just scroll to the top and say get started. So language support, we would like to go with JavaScript, and we already installed these packages, which is GraphQL and then the Apollo server. Now let's get this to be able to just show a hello world application. I'll just copy that and paste it into this file. Now this package is imported just to create a server, and then this is imported just to start the server. And now we need to have the type defs and resolvers. So again, in my notes, I'll just paste something so that you could get them. But instead of into the copy paste, I think I'll just create another file called nodes.md. So the copy paste will be here, and then the notes will be inside this file. Okay, so let's see what are resolvers, type defs, and schema. Now I'll copy all of them and then just paste it. So a GraphQL schema is a fundamental concept in GraphQL. It defines the structure of the data that clients can query. So we will just put our type defs and resolvers. So what is a type def then? So type definitions define the shape of the data available in the GraphQL API. And I think if we create some examples, that's going to be a bit more clear. So let's go ahead and say resolvers. And then we're going to create another folder. Let's call it as type defs. And we'd like to have one type def for user. So I'll say user.type def, and then .js. Then for the transaction, transaction type def.js, and then one index file, because we're gonna merge them into this index.js file and then export it from here, and that's gonna make sense. Let's say transaction.resolver.js, and then we'd like to have the user resolver.js. And then just to be able to work with some data, I'll say dummy data and then create this file called data.js, and you can grab this from the GitHub repo. I'll just copy and paste it. So I just paste that where we have an array of users and transactions, and we'll be using this so that we could just see some examples before we make it any complicated with our database. So back into our nodes, so we have the type defs where we'll just show the shape of the data available in our GraphQL API. And let's go ahead inside the type defs, create one for the user. I'll just close all these files so that it doesn't get any, let's say, complicated. I'll save this file and then close all of them. And it says, let's save all of them and close it. Now inside the user type defs, I'll say const user type def, and then just open up this backtick and then hash and then GraphQL. Now this is a comment, and we're adding this to get some formatting and code highlighting. And for this, you need to install this package. Let's say GraphQL. So I have these packages, the language feature support as well as syntax highlighting. You need to install them as well to get the syntax highlighting as I get. So here inside the user schema, where we'll just say we'd like to have a type called user, and then each user will have a field called underscore ID, which is going to be type of ID, and it is going to be required. So we just put an exclamation point at the end, and that means this value cannot be null. And then we would like to have a username that's going to be type of string and again required. Then we're going to have the name, again type of string, password, string, and then let's say profile picture, that's going to be string, but it could be a null value. Okay, it is not going to be required. And then we'll have the gender, that should be required. And then we'd like to have a special type called query, and then this is gonna tell our schema what kind of queries we could have for the users. So let's say the first one will be users, where we could fetch all of our users, and the response will be an array of users, right? And we say each user cannot be null. And then here we just say we'd like to get the authenticated user, and for this we're gonna return a user. But this is not gonna be like, we are not gonna put this exclamation point, is because if user is not authenticated, then we're gonna return a response with the value of null. But if user is authenticated, then we're gonna return the user. So that's why we're not gonna put the exclamation point at the end. And then we would like to fetch a single user with their IDs. So I'll say user ID, that's gonna be type of ID, and it's gonna be required. As the response, we're gonna send the user. And after this, we'll have a couple of different mutations. So let's say type mutation, and then let's say the first mutation we'd like to have will be sign up, and this is gonna take the input, and this will be type of sign up input, which we'll create in a second. And as a response back, we'll just send the user. And then we'll like to have the login mutation, where we'll just send an input and send the user as a response back. And then the logout, where we'll just send the logout response back. Now let's try to create these inputs and types. So I'll say input, sign up input, where we'll just send the username, which is type of string, the name, and then the password, and I think also the gender, we will send it. Let's say gender, and depending on the gender, we will create an automatic profile pic where we'll just hit an API, and we'll see that later in the video. And then we'd like to also have a login input, where we'll just send the username and then the password. And for the logout response, let's say this could be a type, where we'll just send a message that is type of string. Okay, that's gonna be for our type defs for the user. And let's say export default this user type def. Now if you read this note once more, where we just say type definitions define the shape of the data available in the GraphQL API. They specify the types of objects that can be queried and relationships between them. Now that's exactly it for the user type def. We say this is the type definition for the user, and these are the queries that you could have on the users, and these are the mutations. and these are the related types for them. And for the relationships, we will come back to that later, and it's going to be a bit more complicated. That's why I just put that for the incoming sections. So now we created the type def for the user, and now we'd like to create a resolver for the user as well. And resolvers are functions that determine how to fetch the data associated with each field in the schema. So we had a, let's say, query, which was the user, and for this, let's create a resolver. I'll go ahead and say const user resolver, and that's going to be an object where we'll have the query, and later we'll have the mutation as well. Now inside the query, we said that we'll have the users, right? This is our query where we'll just send the array of users in our database. For now, we don't have a database, so we'll send the hard-coded data. I'll say this is going to be an arrow function where we'll just say return the users. Let's try to import it at the very top. I'll say import users from, let's go one up inside the dummy data, and then data.js file. And don't forget to add this extension, otherwise it's gonna crash. Now we are gonna return this. Let's say export default user resolver, and then we're gonna create another resolver for the transaction. For now, let's create it and just leave it as empty. I'll say transaction resolver, and then it's gonna have the query field as well as the mutation. Let's export this, and then we're gonna create an index file where we just merge both of them. So to be able to merge them, we have created, or we installed a package. So let's import this merge resolvers function from this package, and then we will import these resolvers. Let's say import user resolver from this file, right? And then the transaction resolver, let's say transaction. Okay, it is the correct file. So we have our resolvers. Now we'd like to merge them. I'll say const merged resolvers, and we'll just call this function and just pass it as an array. That's going to merge them into one resolver, and we'll just export default that. Now it is possible that you could not merge them and just put all of them into one file, but that wouldn't be really a clean approach where you just have a really long file, and that would get just unmanageable as your project grows. So we just put them into their own files, and in this way we just know which resolver in which file. And this is what you'll see in production grade applications as well. So now that we have imported our resolvers, merged them, now we'd like to go into the index and just get this resolvers. So we'll say import merged resolvers from this resolvers dot, let's see, from the resolvers and index.js file. So we will say now the resolvers will be our merged resolvers, and for the types we also want to merge them. So we created the user type. For the transaction, I'll just leave it empty for now. I'll say the transaction type def, and then it's going to be GraphQL. Let's go ahead and maybe let's try to add at least the transaction type. So here, let's say type of transaction. This is going to be having these fields, ID, type of ID. Oops, I didn't mean to accept that. So we're going to have a user ID that is associated with this transaction, and then the description, type of string, the payment type, it is going to be type of string. Then we're going to have the category, and then the amount, that's going to be float, and then we're going to have the location. Let's say that's going to be string, but not required. Users could leave it empty. And then date of this transaction. And yeah, that's going to be it. Later we will add the relationships, but for now we could skip that. And for the queries, let's say type query, we could get all of the transactions, and that's how it's going to look like. It is going to be really similar to the user type defs. So transactions get all of them as a response, and then transaction, where we'll just pass a transaction ID, and it is going to send us only one transaction back. And then we're gonna have another one for the category statistics. We could add that later. For now, let's just keep it as simple. And then we'll have the type mutation, where we'll be able to create a transaction. And for the input, we'll just say create transaction input, which we'll create in a second. And then update transaction, and we will just add another input, that is update transaction input. And lastly, delete transaction. And when we want to delete a transaction, we'll just pass a transaction ID and just delete that transaction. Let's just add required at the end for them as well. Now let's try to create these inputs. One for the create transaction input, where we will just pass these fields. I'll copy and paste. So we have the description, payment type, category, amount, date, and location. All of them are required, but not the location. That's what we specified at the top as well. Now we would like to also have one more input to be able to update a transaction. And again, none of these fields are required, because you might want to only update, let's say, the payment type, and none of these, or maybe you just want to update the amount. So none of them will be required other than the transaction ID, so that you know which transaction you're updating. And with that, I think we could export this as well. Let's say export default the transaction type def. So again, when you just take a look at this file, you know that you have a transaction type, and you know you have two queries for the transactions, where you could fetch all of them or you could fetch only one. And for the mutations, you know that you could create one, you could update one, or you could delete one. And that gives you type safety kind of. And then inside the index, now we'd like to merge them as well. And again, we'll be using that package. I will copy that and paste it, which is merge type defs coming from GraphQL tools / merge. Now let's import the user type def. It is coming from this file, and then transaction type def, it is coming from this file. We could maybe put some comments, let's say type defs, and then we would like to just merge them. I'll say const merged type defs. Oops, that should be merged. And then we'll say merge type defs and just pass them into the array. And then let's say export default merge type defs. Now again, I have some comments that I have put, so I'll just copy and paste that. And as I said, we don't need to really merge them into this one file. We could put everything into one single file. But why do we even merge type definitions then? So it is for modularity, easier collaboration. So if we had multiple developers are working on different parts of the schema, merging separate types definitions can make it easier to collaborate without conflicts. And then you could reuse them and clear separation of concerns. I just leave it so that you could have it as a note in this file. Now let's go ahead and save this one as well. And for the index in our backend, for the type defs, we would like to get the merged one. We'll say import merged type defs and get that from this folder and from this file. Now if we say merge type defs, hopefully now we could start our server, and let's save all these files and close all of them. So we have created a script called dev. So let's go ahead and run that. I'll say npm run dev, and hopefully that's gonna work. But I think it is not gonna work, is because we have used the import syntax, but in our package.json we didn't set the type will be module. By default, it is common.js, where you can use the require syntax, but we would like to use import and export. That's why we need to say this is going to be type of module. And if we save now, let's go ahead and say npm run dev. That should hopefully work. So it is starting our server. Let's see. And now it says server ready at this location. Let's copy that and then just paste it. So here we could see by default, you're going to get this kind of tool. And this is, you could see from the documentation, there is something called GraphQL. But since we are using Apollo, this is the Apollo version GraphQL tool, where you could just send some queries without having a React application or any client application. So this is kind of like Postman for GraphQL. Okay, we got a refresh, and let's see. Now here I'll just delete for now all of them, and we could see our fields for queries. I'll just say get users, and we're gonna call this user. I'll just try to zoom in a little bit. It looks like I cannot get any zoom in. Okay, now I'm zoomed in. I hope it is visible. So we would like to get users query, where for each user I would like to get the ID field as well as, let's say, the username. And if you press Control Space, you could get this autocomplete. Let's say get users, and this is the response that we get back. We had this 5 users in our dummy data, and for each of them we got the username, ID, and let's say I want to get the gender as well. If we send that, now here we could see it just gives us all these fields. If I don't want to get the ID, I could delete that, and that's gonna return the fields that I want to have. And that's the beauty of GraphQL again. Now we had also the user. I'll just zoom out a little bit. Okay, we also had the user query, right? I'll press this add to query button. It is gonna add that. I'll just delete this. Now I'll say get user, not users. And for this user, we're just gonna pass a user ID. Let's say user ID will be 3. And let's say for this user, we'd like to get the username. Let's send it. Okay, it says user is null. Maybe the ID was type of string. Let's see from our dummy data. Okay, the ID of users are string, as we can see. That's why we need to send it as an ID, and that should be under the variables. Okay, type of string. Let's get the user. Okay, it still says it cannot get the user. Let's see why this is the case. If we take a look at our server, it is working fine, and I think in our, let's go into the resolvers, we don't have any resolver for that, right? Let's add the resolver now. We'll say user, where we just want to get the user ID, and the first argument is going to be parent. For now, we're not going to be using that, so let's just skip it. And then we have the args, which we could destructure that. I'll say it is the user ID that we are getting. And then this is going to be an arrow function. We're able to say return users.find user._id, because this is the field that we have in our dummy data, right? For each user we have _id, and if it matches with the user ID, we would like to return that single user. I hope now this makes sense, but inside our queries we just get I think 4 different arguments: the parent, and then so let's say parent, then the args, and then the context, and then the info, and we will explain all of them as we use them. For now, we don't use the parent, so I just skip it with underscore, and then for the args, we destructure the user ID because that's what we pass in our client. And let's send this again. Now, if we send that, here we can get the user back. And this is basically what we have explained in this GraphQL diagrams previously, right? We just said that we could send some arguments, or we could just get all of the resources by passing the fields that we'd like to get. And this is basically what we do now. And then we had also different queries. For now, we could get the authenticated user, where we just pass it. But since we got the point, now let's try to move on with our backend code. And once we add the front end, we'll be sending these queries and mutations from our React application. And also, if you want to send some mutation, then you would say mutation, and then give it a name, and then your mutation name. And yeah, that's gonna be it. Let's move on with our backend code. Now, if we head over to the index.js file that we have created in the root, so we see that we are using this standalone server, and we don't want to use this because we would like to have an Express application. And for this, we would like to go into the, let's say, Apollo server, and from the documentation, let's see. If you want to use the Express, I'll just say Express, and there is an API reference where we could just see a complete example. And let's click to that. So there is the TypeScript version as well as the JavaScript. Since we're using JavaScript, that's what we'll be looking at. Now you could take a look at this and just try to understand what is going on, but for now I'll just copy and paste those just to make it work. And it is pretty self-explanatory that we could understand. Now I'll get those two imports, and then maybe put it here. So we have the Express middleware and then the Apollo server plugin during HTTP server. And let's go ahead, import the HTTP as well as the Express and then the course. These are the packages that we have installed. Maybe we could put all these at the very top. And then these are going to be our Apollo imports. Now we'd like to delete this one and then this one, let's say. So they create an HTTP server and then they pass it like this. Let's copy this line and then just paste it. So for the plugins, we're just gonna copy this and then paste it. Now this is basically what we are doing here is what we have done previously, but we just convert that to the Express version of initializing a GraphQL API. So if it looks a bit complicated, it isn't. So let's copy this one and then paste it. Now we have this await and we're just gonna start our server now. And lastly, we're gonna copy these two lines and maybe just all of them. And then I'll just paste them. So here, when we visit the root route, we're gonna call the course middleware as well as the express.json so that it will be able to parse the data that is coming from the request body. And then we have an express middleware for the context. For now, let's just delete this. We're gonna get to what context means when we implement the authentication. So inside an object, I'll just add the request and save it. And hopefully now that should work. Let's go ahead and test it out. I'll refresh this page. Okay, this cannot work. Let's see the terminal. So it says app is not defined. Let's create an app. And we'll just call it from Express. Okay, now server is ready. Let's refresh. And here it is just working as expected, just like previously. But now let's test it out. We'll just say give us the username and then the gender for each user in our database or the dummy data. Let's send the query and this is the response we got. So this is the exact same thing that we have done, but we just converted to the Express version of it. So now that we have a basic understanding of GraphQL, let's try to add our database connections, our models, and rest of our logic. So inside the backend, I'll create a folder called db and then another file called connectdb.js. And here we'll just basically try to connect to our MongoDB database, which we don't have, but we'll create in a second. Let's import the mongoose from mongoose package, and then we'll create a function called connectdb. That's going to be an async function. We'll have try catch, and then inside the try, let's say const connection. That's going to be await mongoose.connect, where we'll just pass our process.env, which is an environment variable. That's going to be Mongo URI. And once this is done, we will just say console log MongoDB connected, and we could just show this connection host. And inside the catch, let's say this is an error. I'll just rename it. And I'll say console.log the error, and then I'll just say process exit with the status of 1. That means there was some problems or errors. And that's gonna be it for our function. Now we'll like to create this Mongo URI under the .env file. Let's paste it, and we're gonna put some values here once we create our MongoDB database. And then to be able to use it, we need to go after, let's say, our imports, we would like to say .env, which we need to import first. I'll say import .env package from .env, and then we'll say .env.config. So if we don't call this function, we can't really use this environment variables. But if we add this config, now we're able to get the values just like we did here under the process.env. And then now we don't really want to expose those .env variables. So I'll create a .getignore file in the root, and I'll say don't add the node modules to our git, and then I'll add the .env. And since we are here, let's try to initialize a git repo so that we could maybe just push it into the GitHub in the deployment part. So I'll say git init, and if you already did this, so just skip this section, git init, and then just press enter. That's going to be in the root. It's going to initialize it. And let's see, here we could see now .env has been ignored and node modules is being ignored as well. Let's kill this terminal. And then we would like to create some models inside the backend. I'll say models, and here we would like to have the user model as well as the transaction model. Let's start with the user model. I'll just close these files so that they are not distracting, and we'll import the mongoose, and let's say const user schema. That's how we would create a model. First we create the schema, and then depending on that schema we create a model. So I'll say new mongoose.schema. That's gonna take an object, and here we're just gonna put our fields, which we're gonna have the username. That's gonna be type of string, and then required, and then unique it is gonna be. So we'll say unique true, type string, required true, and then we're gonna have a name field. Let's say type will be string, and it's gonna be required. And for the password, I think at this point I could copy and paste that because it is relatively simple to understand this code. So password will be type of string and required true, and then we'll have the profile picture where it's going to be type of string. By default, that's going to be an empty string. And then lastly, we'll have the gender where it could be, let's say, just paste it. It's going to be type of string, but it's going to be enum. So it's either going to be male or female. And after this, we could add another object where we'll just say timestamps will be true. So this is going to add the created at and updated at whenever a user signs up. And depending on that created at field, you could show something like this user is member since, and then the date. So we got the, let's say, schema. Now I would like to create the model. So const user mongoose.model, and past this is going to be the user model, and make sure it is capitalized and let's say singular, and then pass the user schema, and lastly export default the user model. And we would like to do the same thing for the transaction, and let's import the mongoose. Let's say const transaction schema, oops, and that's gonna take an object, and here we'll just have our fields. Now this is gonna have a user ID that's gonna be referencing to the user model, and it's gonna be type of object ID. So this is coming from mongoose, but basically this means the transaction will have a user ID field that is going to be referencing to the user's model, and this is going to be required. And then we will have a description, payment type, category, amount, location, and date. I think at this point I could copy all them and then just explain one by one. So we have the description, that's going to be string and required. Payment type is going to be either cash or card is required, and then category will be saving, expense, or investment. And then we'll have the amount, it's going to be required. Location will not be required, and by default we could say it's going to be unknown, and date will be required as well. But this date is not created at or updated at, but it's rather like when this transaction has been created, and this will be depending on the user and inside that form. So let's say const transaction, and we're gonna just export default this model. So this is gonna be it for our models. Now next, let's try to create a MongoDB database. So head over to the mongodb.com, and if you don't have an account, create one for free. I already have one, so I'll just go ahead and log in. And once you log in, go into the projects and try to create a new project. I'll just call mine as expense tracker, and I'll just say next. Now the project owner is gonna be me, so I'll say create the project. So it's gonna take a bit time, and then it's gonna take you to this page. Let's say create a deployment, and then you'd like to go with the free tier, and then I'll say create. Now we'd like to create a user, and the password is important here, so let's just copy that and paste it into our .env file for now, and we'll just use it. So after you copy that, say create user, and it's gonna create the user. Now we would like to press this button that says add my current IP address. I will not press that because it's going to expose my IP address and I don't want to do that. But I'll just pause the video here, press that button, and then at the very bottom of this page, we'll see a finish and close button, and we need to click to that. Once you do that, we'll just move forward. Okay, so I have added my IP address and I press that button that says finish and close. Now we are in this page. We'll say connect from our application, and we're gonna get the connection string. Now let's go ahead and paste it to this Mongo URI field, and then the password is gonna be this one that we have copied. I'll just replace it, and for the database I could say something like GQLDB, which stands for GraphQL database. And then we already use this Mongo URI in our function, right? We said that connect to this Mongo URI, which is our database. And then in our index.js file, we could go ahead and say, after we start our server, we'll like to say connect db function. Let's see, we cannot get it for some reason. Let's try to import it manually. We'll say import connect db from under the db, and then connectdb.js file. Now if we call this function and save it, hopefully we should be able to see that MongoDB connected in our terminal, and here we go. Now we are connected to our database and our server is ready. Now we could put a commit that says, maybe let's just open up a new terminal. I'll just add everything to this staging area. I'll say git add all, and then git commit, and then our message. So here we could put anything really. I'll just say project boilerplate setup, and then I'll just commit this. Okay, so I have committed that, and the next step is gonna be the authentication. Okay, so now we are in the authentication part. Now instead of immediately jumping into the code, let's just see how things works behind the scenes, and then we'll just try to implement that. Now first, let's just imagine we have a user that wants to sign up or log in. They will send a request to our GraphQL API, and then we will use a package called Passport.js, and we will initialize it in a way that it's going to run the local authentication strategy. And that basically means that user is going to send the username and password, and depending on that fields, we'll just try to sign up the user or log the user in. So any of these are, let's say, successfully completed, Passport.js will try to serialize the user object and store it into our session store, which is going to be MongoDB. Now, what is serialization means? I have a note here. Let's see. So serialization is the process of converting the user object into a format that can be stored and retrieved easily. So basically, we're going to take the user object and convert it into a way that we could store it in our MongoDB session store. So will this typically be the user ID, and in this way we're able to uniquely identify the user. So we know this user now is authenticated. And once we store it in our session store, then we're going to create an HTTP only cookie from the server, and then we will send it to the client. And the name of this generally be something like connect.sit, which stands for session ID. And for the subsequent request, now this user will send the let's say it's going to send a request back to our API, and they want to maybe create some transactions, delete some transactions, update, so just anything that needs authentication. They will send the HTTP only cookie along with the request headers, and then so let's say our server will compare that cookie with our session store, and if they match, then this user is authenticated, and then we'll basically log that user in, or I'm sorry, we'll just let them to do whatever they want to, because this is the subsequent request, right? So they want to create the transaction, we check, okay, this user is authenticated, so here you go, you could do and just create that transaction. And for this, we'll be using the Passport.js package, which is, you could take a look at the documentation from passport.js.org. Now, there are lots of different strategies, and by the way, Passport is authentication middleware for Node.js, and it is extremely flexible and modular, so really great package that you could take a look. And then we have lots of different strategies. Now there are things like Google authentication, GitHub, which is the one that we have used in the last video, but in today's video we'll be using the Passport local strategy, and here we could see it is the username and password authentication strategy for Passport. Now, using this is really fine, but the implementation you see here is mostly for REST API, and if you want to just modify it for the GraphQL, that would be kind of pain, and like you could still implement that, but instead there is a package that we'll be using that just makes things a lot easier. And this is the GraphQL Passport, and it is still up to date, so really great package that we'll be using. And then before we jump into the code, let's take a look at the demo, how this works, and then yeah, we'll just take a look at the code. Okay, so this is the demo application that I have, and this is the other MongoDB account that I have, which stores the demo applications database. So we have a couple of users in our database, and we have some transactions that I have used while before recording this video. And for the sessions now, we don't have any sessions. So let's go ahead and try to log in. So there's an account called John Doe, and the password is 123. Now inside the cookies, we don't have anything. But when I log in, we said that we're going to have a cookie called connect.sid. So let's try to log in, and inside the cookies that should be created. And there we go. Now we have the cookie, which is HTTP only, that we could see from here. So it is HTTP only. That means nobody can access this via JavaScript, and it just makes it a lot more secure than a cookie that is not HTTP only. And then if we take a look at the MongoDB account, so we didn't have any sessions. Let's refresh. And then there we go. Now we have a session that will expires in 7 days. And this session has the passport field, which stores the user ID. And just like we talked in the workflow in that diagram. And this is the user ID for John. Let's just double check. It ends with 7AF. And let's go into the users. We have the John, and his ID ends with 7AF. So this is basically it. Now we are able to create transaction, update transactions, and just delete the transactions. We'll just send it. It's going to deserialize the user, and it just deleted that. And it was possible because we are storing this session ID from here and in our database, and they are matching, so we are able to just delete that. Now let's go ahead and try to log out. Now that's cleared our cookie in our client. I'll just zoom in a little bit maybe. And then here, if we go take a look at inside the sessions, now we don't have any sessions, and it has been removed. Now that means that user has been logged out. So that's the general idea. Now let's go ahead and try to implement this in our code base. Okay, so we said that we'll be using a couple of different packages, which was the Passport and then GraphQL Passport. Now, even if you are implementing other kinds of strategies like GitHub, Google, whatever you see from here, you still need to install this package, which called Passport. And this is the core functionalities that is going to give you for the Passport package. And let's go ahead inside the index where we would like to import a couple of packages. And also we installed this package, which is going to allow us to store the sessions in our MongoDB account. And then we also have, let's see, the Express session. And again, we'll be using this to store some persistent sessions in our application. Now let's go ahead into the imports. I'll just import 3 different packages. which are gonna be the passport. It is coming from the passport package, and then the session, and then the connect Mongo. Now we'd like to go maybe above this server, and we'd like to create a store first. And even before that, let's say MongoDB store, and we're gonna call this connect Mongo, and then just pass the session into it. And here we'll just say const store. I'll just scroll a little bit, and then new MongoDB store, which takes an object. So call the function. It is gonna take our connection string to our MongoDB account or database, which we have already created inside the .env. So I'll go ahead and I'll say URI will be process.env in Mongo URI, and we would like to store this inside the sessions collection that we have seen just in the demo. So I'll just say collection will be the sessions. And now if you want to like for debugging and error handling purposes, you could add the following code, which will be store.on, and if there are any errors, you could handle that. Or for now, for debugging purposes, let's just say console log it. So I'll say console log the error, and we could even make this one-liner by deleting this curly braces. Okay, just like this. Now below this, we'd like to also go ahead and add another, let's say, middleware. Maybe, yeah, above the server, that could be, let's say, app.use. We'll call the session middleware. So I'll just say session, or maybe we could go just give a bit space for ourselves, and we'll say session, call it. That's gonna take an object, which will be our options. And then here we'd like to first pass a secret, and let's create a secret in our .env file. I'll just say this is going to be session secret, and I'll just say my secret 123, but feel free to make this a little bit more complicated and hard to imagine. Okay, I'll just save this one, and let's go ahead and add our other options. The one will be resave, which generally like 90% of the time you keep it as false, and then the save uninitialized will be false. Now I'll just put one comment for this one. So this option specifies whether to save the session to the store on every request. And we don't really want to do this because otherwise our MongoDB account would have lots of different sessions. And if you hover over this, you could read the implementation and some suggestions. They just say most of the time you would like to use false. And same applies for the save uninitialized. So I'll just put a comment so that you have it, and feel free to read it. So after this option, we'd like to have another one, which will be the cookie. That's going to be an object. We'll say this will expires in 7 days. And this is how we could do it. Like, so basically, yeah, 7 days, 24 hours, 60 minutes, 60 seconds, and 1000 milliseconds. I think that's how it works. This expires in 7 days. And then we'll just make it HTTP only to true. And this option prevents the cross-site scripting. So I'll just paste it. And if you want to learn more about this attack, just feel free to Google it. And lastly, we will try to add this store, which is our store. So that's going to be it for this session middleware. And then after this, we'd like to initialize the passport. So we'll say app.use, and let's just scroll a bit. So passport.initialize, and then for the session management, we would like to also say app.use passport.session, and that's going to be it for the initializing the passport. And we would like to have the context, and we said that we'll just talk about it later. So now it is time. So context is basically an object that's shared across all resolvers. So we had a couple of different resolvers, and we'll get this as the third argument. So this first and second, and the third one will be the context. And whatever we put into this context, we'll be able to use it. Now we pass the request, and let's say we'll get the response as well. If we pass it, now we are able to just destructure the request and response in all of our contexts. So here we'll just get the context as well. If we wanted to, we could take the request and response, and that's going to be important when we implement the authentication. So for now, let's save this file, and here, instead of doing it like this, if you take a look at the documentation for this package, then you will see that they are using this build context, and let's try to import it. It is going to be coming from this package. Let's go ahead and just import it at the top. Maybe below this I'll put it, and we don't want to use this one for now, and we'll just take the build context, and inside the context we'll just paste it. So we call the function with this request and response being passed. So we could also specify the course. Let's say our origin will be, which is our React application, will be on localhost at this port, which is 3000, and then we'll just say credentials will be true so that we could send our cookies alongside the request. And I think that's gonna be it for this file. Now we would like to implement the passport. Let's go ahead inside the backend. We'll create a folder called passport, and here I'll just say passport. You could say just JS, but I'd like to call it as config.js. And here we'll just add a couple of different things that we'll just get from the documentation. If you want to, just feel free to read it, but I think I'll just take a look at from my notes and write it and explain it. So here we'll import a couple of packages, but first let's save this file, and then here we'll just get the passport, and then we'll get the bcrypt package. Let's say import bcrypt from, oops, there is some typo here, so I'll basically copy and paste it. Get the passport from passport and get the bcrypt from bcrypt.js, and this will be used for hashing the passports, and that's going to make sense in a couple of seconds. And then we'd like to import our user model. So let's say from models, and we called it as user model.js. And then we'd like to get the GraphQL local strategy that we have seen from the documentation. It is going to be this one. So I'll just copy this line completely and then just paste it, delete the build context. And that's going to be it for our imports. Now we'd like to create a function. I'll just say export const configure passport, and that's going to be an async arrow function. So here first we need to type passport.serializeUser, which will take the user and then a callback called done. And then let's go here. Now basically this function will be used to serialize the user and the things that we just talked about in that diagram. So we'll just say done, and we don't have any errors. It's going to be null, and serialize it with user._id. So this _id field would work fine, but that's going to be type of object, and if we just pass it as id, that's also going to work. So either case, that should be fine, but I'd like to go with this version. And if you want to console log something here, let's say console log and serializing the user. Oops, I didn't mean to do this. So when you send a login or sign up request, this function will run and you'll see this console log in the terminal. And let's just leave it like here, and we'll see that in action. And then we'd like to add another, let's say passport.deserializeUser, and we could see this from the documentation as well. So maybe not in this one, but if you take a look at the actual passport local authentication, there are some examples that you will see. They are also using this passport serialize user function and deserialize user, and this is where I took these functions. So this is going to be an async function where we'll take the user ID so that we could deserialize that, and then the done callback as well. Let's close this function, and here you could again just say console log deserializing the user, and then we would like to have a try catch. So close the try, and then here we'll say catch, which will take the error, and then we could do some error handling. And let's say const user, we'd like to find this user from our database, which will say user.find by id and then pass the user ID. And after this, so once we find the user, we'll just say call the done function, which error is going to be null, and the user will be this user that we just found. And then for the catch, that means there were some errors. We'll just call the done function with the error. And that's going to be it for these two functions. Now we'd like to lastly add our passport middleware. So passport.use, just call it. And this is something you could see from the GraphQL documentation. So let's just scroll a little bit to top. Okay, so this is basically what they are doing, and we'll implement our own logic. Inside this middleware, I'll just say new GraphQL local strategy that we just imported at the top, and close this function. That's gonna take an async callback where I'll just get the username, password, and the done function. So basically that's gonna be our login function, and we'll see that again in our resolvers. How we'll be calling this. So we'll have the try catch. In the catch, let's get the error, and we'll just say return done with the error. And now let's do the try. So we'll say const user. Again, we will find the user. We'll say user find one with this username, and if this user does not exist, we could say, let's say if there is not user, I'll just scroll a little bit, we could throw an error that says, maybe let's not say user not found. Instead, we'll just say invalid username or password. So when users log in into your application, you don't really say this is a incorrect username or this is an incorrect password, but instead you just specify it is invalid username or password. This is known as a good practice, and that's what we are doing here as well. Then we'll just check if the password is valid. So I'll say valid password, and we'll say await. Now we'll be using the bcrypt, and we'll say compare, and now we're gonna hash the password when they sign up. So let's say they just put a password like from 1 to 6, we'll just take it and convert it into some string that is not really readable. So it is gonna be looking like, let's say, something like this. And the reason that we do this is just the best practice. And if someone steal our database, they shouldn't be able to see all of the passwords. So you never store your password as it is, but instead you just hash it with this bcrypt kind of package. And then we'll just say bcrypt should compare the password that user passed with the password that is in the database. Now again, we'll just do the same thing. We'll say if it is not a valid password, we'll return the same error that says invalid username or password. But if we pass this one as well, that means that was a successful login. We'll just say null and return the user. Now that's gonna be it for this file, and we need to call this configure passport in our index.js. Let's go at the top and just try to import it. Okay, so I just import this function from the passport.config.js file, and below this .env config, we could call the configure passport function, which is going to basically configure it. And then here we initialize it and initialize the session, as well as like passing our stores into this session middleware. Now, hopefully the passport configuration should be completed, and if there are any errors, we'll just see that when we implement the client part. Now let's go ahead and try to add a commit. I'll say git add all, and let's say git commit -m passport configured. So that's going to be the commit message. Let's commit this, and now in the next section, we'll just try to implement the user resolvers. Let's go ahead and first try to implement the mutations. I will cut this and then just paste it at the top. And first we would like to implement the signup function. Now, if you remember, that's gonna take, let's say first signup, that's gonna be the async function. And as always, that's gonna take the parent. We don't want to use it now, and we'll get that what that means in the incoming sections. Then this was taking an input. Let's see, inside the type defs, we had the user type defs. Inside the mutation and inside the login and signup, we take an input, right? And that's going to be type of signup input and login input. And inside the signup input, we have these fields. And now we'd like to just destructure them. So also we'd like to get the context, which we have the request and response, which we passed it here, right? And we'll be using that as well. Let's close these files. And now here, let's wrap it with a try catch. We're gonna get an error and we'll handle it. For now, let's say we'd like to get the username, the name, the password, as well as the gender, which are coming from the input. And if any of these fields are empty, we're just gonna throw an error that says, please fill all the fields, or like all fields are required. But if this is not the case, first we'll check if user exists in our database or not. Let's import the user model. Okay, so First, we need to check if there is a user exists in our database with this username. If this is the case, we'll just say user already exists and we're not gonna sign them up. But instead, if they pass this check, then that means we could successfully sign up them. So we're gonna create a salt, let's say const salt await bcrypt, and we need to import the bcrypt as well. Let's say import bcrypt from bcrypt.js, and we'll just say gen salt. This is gonna generate a salt, let's say 10. Now I will explain what that means in a second. Let's say const hashed password, and we're gonna take the user's password. Let's say await bcrypt, and then bcrypt.hash the password user just passed in with the salt. Now, as I said, if we had a password like 123456, that will be converted into something like not readable. And when we pass gen salt as 10, I think it's gonna be in the length of 10. But if you just make this number a little bit large, let's say 20, 50, this is gonna be a bit more secure, but that's gonna take longer to create the salt. So the number 10 is a good value to keep it like that. And we create the salt. Now we say hash this password with the salt. That's basically the idea. We hash the password. Now we'd like to create a profile picture for this. And for this, we'll be using an API. I'll just paste it so that you could have it as a note. Let's visit and see what this is. So basically, this gives you boilerplate or random avatar images. Okay, so you just see from males or females, and you just hit the endpoint. That's gonna create random avatars. And if you want to make it unique, let's say, I think it was maybe at the top inside the document. Now they say create a unique avatar with username. So let's copy this and paste it. Now, if this is Scott, when you refresh this, that's gonna always give you the same user profile picture. But if you try to just, okay, let's try to here. But if you try to send a request to this endpoint, whenever you refresh, you're gonna get different profile pics, and we'd like to make it unique. And for this, we'll just pass a username. So if this is John, we're gonna always get this profile picture. And we could make it for girls. Let's say that's gonna be girl, and let's say Jane. Okay, this is the idea, and that's what we'll be using. Now inside our code, let's say depending on the gender, we're gonna create it. So I'll say const boy profile pic, and we're gonna hit this endpoint. So just from the documentation, I took it, and let's make it backticks. So for the boys, we're gonna pass the boy here, and then the username that we got from the input. And we'll do the same thing for the girls. So I think I'll just copy that and paste it. Okay, we just changed this part, and we just passed the username. Now we'd like to create a new user. So let's go ahead and say const new user, and we'll say new, call the user model, and we'll just pass an object. And then we'll have the username, and then the name that we're getting from the input. We'll say the password, which is gonna be the hashed password that we just created above, and then we'll get the gender and just pass it. But for the profile picture, let's say if the gender is equal to, if it is equal to male, then we're gonna set this, right? But if it is female, then we're just gonna pass this as the profile picture. And after this, we'll say await new user dot save, and we're using await because that's gonna take a bit time in case you don't know what that does. And now we'll just say await context dot login. Oops, not error, but that's gonna be a login, the new user. And you could see these functions from the documentation as we talked about it before. So context.login logout is authenticated in is unauthenticated, get the user, and this authenticate function as well. And we're using the login in our case. And after this, we'll just say return the new user. In the catch, we'll basically say, I'll just copy and paste that. For the debugging purposes, we'll say console.log error in, let's say, sign up. And we'll just we'll just throw an error that is either error.message. If there isn't any, we'll say something went wrong in the server. And that's gonna be it basically for our sign up function. And now we'd like to create the login function. So I'll just scroll down a little bit and let's see, this was the sign up, right? We'd like to go ahead and create the login resolver or the mutation. We'll just say async, that's gonna take the parent, and then that's gonna take, let's say, the input. Oops, that should be inside. So that's gonna take the input and the context, and that's gonna be an arrow function. Let's go ahead and say try catch. In the catch, we're gonna get the error, but first do the try. So const, we're gonna get the username and password from the input, and then we will just say await context dot authenticate, and we'll pass this GraphQL local that you could see from the documentation for the GraphQL passport package. And then this requires an object where we'll just pass the username and then the password. Now this is gonna send us an object back which has the user inside. So we'll say if we have the user, right? If that was successfully completed, we'll just say await context, if I can type, dot login. So log in the user and then just return the user back. So here inside the catch, I think I'll just copy and paste it as well. We have one console log that says error in login function, and then let's say that should be error, and then we'll just throw the error. And lastly, we'd like to add another mutation that's going to be the logout. So we'll take the parent, we don't have any inputs, so I'll just put a double underscore and then the context. Now if you want to, you could like destructure the values from the context, such as login, and so we used login, yeah, and then we could take the authenticate, but I just want to use it with context, so feel free to what you'd like to choose. And then let's go inside, we'll have the try catch, and I'd like to get the context, and we are missing, let's see, okay, we are missing the arrow. Let's say for the error, again, I'll just maybe copy and paste these lines. Let's say error in logout. Most of the time we don't get any errors when you log out, but in case we have, so we'll say await logout, and that should be coming from context.logout. And we'll say request.session destroy it, which runs the error callback. If there's any errors, we'll just throw it, but otherwise we'll try to clear the cookies from the response. So res.clear cookie, and as we have seen inside the demo, that was the connect.set, right? So I just showed that when we tried to log in our demo application. And then for the return, we'll just return a message that says logged out successfully, and we need to pass it like this. And let's see, we are missing some kind of brackets or something like that. Okay, we need to throw an error. Okay, let's send it. Now it's working fine, and we are returning a message. I'll just give a bit space. It's because inside our type depths we said that the logout function will just return, or the logout mutation will return this logout response, which is an object that has the message field. It is type of string, and that's what we return. So we have added all of our mutations, right, under the mutation. Now we'd like to add our queries. So we said that we're gonna have the users, we would like to fetch all of them, but that was only for testing purposes, so that we could see that inside that graphical tool. I don't really want to add this. So we don't need to get every user in our application. We just want to get the authenticated user to check if they are logged in or not, and then just one user profile. And so we need to just delete this. I don't really want to use this. And I'm going to save this file. Inside, we're going to delete this resolver as well. And let's add the auth user, which is going to be an async function. Parent, we're not going to be using it, and we're not going to use the args. Let's skip it, and then we'll just take the context. We'll have the try catch, In the catch, we'll just have an error. As always, I think we could copy and paste it. I'm not sure if it is annoying, but we're just saving a lot of time. So error in auth user. And now inside the try, we'd like to, and let's put a comma here. Inside the try, we'll just say const user, would like to await context.get user. And there is a function like this inside this context. And again, you could see that from the documentation. So we got the user, and we'll just return the user if they are authenticated. And that's going to be it for the auth user. Now we'd like to fetch a single user as well. I'll just say this is going to be an async function. We'd like to skip parent. And for the args, we're going to take the user ID. And let's go ahead, create the function. We'll say try and catch. In the try, we'll say const user await user model find by ID the user ID, and we'll just return this user profile. Now we are not using context because we don't really need it. We'll just return the user object to the client. If you want to make this authorized, feel free to add it. And then inside the catch, we'll just have the error, and I'll just, I think again, copy and paste it. So error in, let's say, user query, and then we'll just throw an error that says error in getting user. Maybe we could say error.message. If this does not exist, then we could return this. And that's gonna be it for our resolvers. Lastly, we'll just add a relationship. I'll just put a comment. We'll say add, and let's say this is gonna be a to-do. Add user transaction. I'll just put slash relationship, or maybe let's just say relation, and that's going to be something later in the course. So we haven't seen the relations. Yeah, we'll just leave it for later. And with this, we have completed our user resolvers. At this point, you could just pause the video, take a look at how it works, what we have done. We have created 3 different mutations and 2 different queries, and they are matching with our schema. If they don't match, we're going to get an error when we try to send queries or mutations. With that in mind, let's go ahead and add the transaction resolver. And at this point, we could add another commit. You could either add it from the terminal, or you could go ahead here, let's say, add all of them to the staging area. And we could basically say user resolvers added and just commit it. Okay, now we don't have any changes. Let's go ahead and try to add this transaction resolver next. Okay, so let's take a look at the schema, what kind of queries that we're going to have for this one. We just have 2, which is the transactions, where we fetch all the transactions and then just single one. And then we have 3 different mutations to create, update, and delete. Let's go ahead and add all of them one by one inside the transaction resolver. Now inside this query, I'll just say we have the transactions, which is going to be an async. I'll just auto accept this for now. And we're going to have the try catch. So in the catch, we'll handle the errors. But for now, let's say if context dot get user, if it is empty, that means user is unauthorized. We could say throw new error unauthorized. And if you want to, you could make this one-liners like this. And then after this if check, we'll just say const user ID, and we'll get that from the context dot get user and then underscore ID. I think we need to await this. That's going to take maybe a bit time. And then here I'll just say const transactions, where we'll just say find inside the transaction model. Let's import it at the top. Okay, I just imported that from the models transaction model.js file. And we'll say find the transactions for where the user ID that should be. So inside the transactions, if you remember, we had this user ID field, and we'll just say find all the transactions that are associated with this user ID, and we could shorten this by deleting this part. Now we got the transactions. If you want to, you could console log it just to see how it looks, and I'll just skip it for now, and then we'll just return the transactions. And we're gonna have some errors in the catch. which again, I just copy and paste the error messages. We'll say error getting transactions, and then we'll just throw that inside this error constructor. And then after this transactions, we'd like to get one transaction. So transaction, that's gonna be again, we'll just skip the parent, take the args, which is gonna be the transaction, and I think we don't need context. So here we got the transaction. Let's see inside the schema and just double check it. So we were in this query where we just sent the transaction ID, and let's add the try catch, and inside the try we'll just say const transaction, where we'll just find the transaction by ID. That's gonna return only one transaction. So we'll say transaction ID and then call it, then we'll return this transaction. And in the catch, now this code is pretty self-explanatory, right? So I'll say console, maybe I'll just copy and paste it. Oops, that should be inside the catch. Okay, I just paste the console error that says error getting transaction, and we just throw the errors as always. Now we'll have another query, and we said that we'll be adding that later, which is going to be category statistics. Maybe for now we could skip it and just add a to-do. We'll say, okay, let's make it like this. I'll just say add category statistics query, and let's copy this, paste it into the type defs as well. Okay, that's the to-do we'll be doing later. For now, let's keep it simple, and that's gonna be it for our queries. Now I would like to add our mutations, and I'll just shrink this one. Under the mutations, we'll have one called create transaction. Okay, I initialize the create transaction mutation, which is this function where we get the parent, args, and context. Now I'll just duplicate this twice, and this is gonna be, let's say, update transaction, and this is gonna be delete transaction. And let's go ahead and first add this one. We don't really need the parent, and again, we'll just explain that later. I just keep saying this, but just that we'll be adding that later in the course. And then we'll have the transaction ID where we just get it. Oops, sorry, that shouldn't be really. We'll have the input for the transaction, because let's go into the type defs where we said that we're gonna send an input for create transaction and update transaction, which is gonna be these types, right? This one and then this one. So we take the input. Now we'd like to destructure a couple of different values. Let's create a try catch. In the try, we'd like to say const new transaction, and we'll just try to create one. So instead of destructuring all of them, we could just spread it. So I'll just put 3 dots and we'll say input, and this basically will take every input from the user, that is the description, payment type, category, amount, date, and location, and just spread it into this object. So we don't need to come here and just say date, input.date, and let's say the location, input.location, and you get the point. Instead, we'll just spread it, and that's gonna make it a lot easier. And then we also need to pass the user ID, which is gonna be the context dot get user dot underscore ID, because we had the user ID inside the transaction, right? It is gonna be this one. This means this transaction is associated with this user. So after we have the transaction, we'd like to save it. So I'll say await new transaction, save it to the database, and then just return this transaction. And for the errors, we could just do the same thing that we have done. Okay, that's gonna be it for this mutation. Now we'd like to go ahead and add the update transaction. And in this one, again, we don't need the context. We'll just get the input, and we'll skip the parent. Oops, I didn't mean to do this inside the view. Let's just zoom in. Okay, I'll just put an underscore. That means we just skip that. So inside the try catch, now we'll just say const updated transaction. We'll say transaction.find by ID and update. Then we will put the transaction ID, and this means we would like to update this transaction. We passed ID, and we would like to update these fields where we'll just pass the input object. And optionally, we could also put new, that means like new to true. And if you hover over this, new, it says by default find one and update returns the document as it was before. And if you set the new to true, it will give you instead the object after the update was applied. So we're just going to get the updated document, and we will say const, or maybe just return the updated transaction. And for the errors, again, we'll just send it. And then lastly, for the delete transaction, we'll skip the parent. We don't need the context, and we'll get the transaction ID to delete this transaction. At this point, we could just copy and paste all of them. So we have a try catch. In the try, we'll like to find by ID and delete that transaction where we just pass the ID, and in the catch, we just throw an error. And here inside the transaction, also we'd like to add a relationship, but for now, let's say to do, and we'll add the, let's say add the transaction / user relationship. Okay, so we could save this file as well. And that's gonna be it for the transaction resolver. Now we have created, I think, 2 different queries, and we have a to-do. So it's gonna be 3 queries in total. And we have the, let's say, 3 different mutations. And we'll also add a relationship later in the course. So that's gonna be it for this one. Now let's try to just commit this. I'll add all of them to the staging area, and I'll say transaction resolvers added, and just commit this. So I think that's gonna be it for this part. Now we are ready to work on in the front end part, where first we'll just try to build our UI design, and then we'll try to connect it to our backend. And if there is anything missing in this backend part, we'll just come back and add all of those changes. Okay, now we would like to create a React application on the client side. So for this, let's open up a new terminal where we'll just cd into the front end folder, and here we'll just create a React application. So let's say npm create vid at latest, and since we would like to have this application inside the current folder, so I'll just put a dot at the end. And this is going to ask us a couple of questions where we'd like to go with React and JavaScript. Now it says type npm install to get your node modules. So let's say npm install, and that's going to install our packages inside the front end. And then we'll just run npm run dev. That's going to open up our development server. Okay, so it's been completed. Now we'd like to say npm run dev, and control click to this one, or maybe I'll just copy it because I have a couple of different tabs open where I'll just want to go into this one. And that should be our like boilerplate starter React application. The first things first, I just want to update this port to be, I'll just change it. So I'll go here, I'll say server, and then here there is port. Yeah, it's gonna be port, and I'll just put 3000. So let's save. And now if we refresh this page, this is not gonna work, but on this port it should work. Okay, we have our React application. Now we would like to set up Tailwind CSS. Let's go and say Tailwind CSS vid, and that's gonna give us an installation guide where we already created a React application. So we'd like to install our dependencies. Copy this, and then go back, open up a new terminal, and then just cd into the front end, and then just paste it. Now it's gonna run the first command, which is this one, and once it is completed, we need to run the second command. Okay, now it's been completed. Press enter again. That's gonna give us the tailwind config.js file. And for that, we need to go ahead and copy this file, and we'll just replace it with this one. This has been completed. Now we have the tailwind config.js, where I'll just paste the one that we have copied. And lastly, we'll go into the index.css, just delete everything and delete the app.css file. Okay, in the index.css, you'd like to just copy these 3 directives and paste it. Inside app.jsx, we'll just remove this boilerplate code, and I'll say h1 hello, and then I'll just say class name text red, and let's say 500. Delete this one and maybe all these. Oops. Okay, so if we just save it like this is not gonna work initially. We cannot see that color, it is not red. And if we open up our terminal and then just shut this down and then reopen that again, it should work. Let's refresh. And here we can see the Tailwind CSS classes are working. And now we could just add as much as we wanted to. So let's say text is gonna be 5x large. And if we save, here you can see it is working. We could add padding, background of, let's say, blue 500, so on and so forth. It's just gonna work. And if you don't get this kind of highlighting, or when you control space, if you don't get this autocomplete code, there is this extension, Tailwind CSS IntelliSense. You need to install this, and after that it should work as expected. So now let's save this file and let's take a look at the demo, what we'll be building. We have this kind of grid background, and for this we'll be using a UI library called Aeternity UI. It has really different components, and it's been getting really popular, where you could see from the Twitter, from the YouTube. It's just been really hyped up, and it's a super great component library. Let's go into the components, and then here we'll like to use the background. Okay, now it has different backgrounds such as grid small, and then there is this dotted. Okay, but we'd like to use this one. And now this is the code, how you would use it. And then they say install these packages. Now we could copy this and paste it, but instead of just copying these, let's install all of our packages that we'll need for the client. So if you go into the GitHub repo under the copy-paste.md, you will find these dependency scripts. We already installed backend dependencies, which were this one. If you remember, it was previously in the video. And now we'd like to install the front-end dependencies. Let's copy this and paste it into our front-end terminal. Okay, here we could see, I'll just shrink this. We have the GraphQL Apollo client, React Router down for routing, and React icons for some icons, and React hot toast. If you don't know what that is, we'll get into that. And Tailwind merge, which this one uses. Here you could see Tailwind merge, mini SVG data URI, CLSX, framer motion. So these are the packages we installed. And then we also installed chart.js and React chart.js 2 package to be able to have this chart. So that's going to be our packages. Just install them, and whenever we use any of them, we'll just try to explain. So I'll just press enter and make sure we are under the front end. Okay. So packages have been installed, and if you take a look at their documentation, they say create this utils folder and then cn.ts. Let's copy this and we'll go into the source, create that utils, cn.js, because we're using JavaScript, not TypeScript. So I'll just paste it, and we'd like to delete this TypeScript specific part. And that should be it for this file. And let's see what they say else. So they say update the tailwind config.ts. Now this is TypeScript and Next.js version. So instead I'll give you the one that I have created. And the way I created is basically I take a look at their code and just convert it to React in this V2 version of it. Okay, so I'll just select this entire file and then just paste it. And again, you could find this from the repo under the tailwind config.js file. And if you compare this code with this one in the documentation, you'll just see they are mostly the same, other than some TypeScript specific thing that has been removed. Okay, we're gonna save this file, and this basically adds the background grid background grid small class and then background dot class, and we'll be using this one. In case you would like to use these, I'll just leave it here, but if you don't want to use them, I think you could just delete those. But that's gonna be it for this. Now in this part, we are not gonna be writing too much code, but rather we'll just be copy and paste. And the reason is we'd like to just move faster and not really focus on the UI where we'll just have CSS classes. And this is a GraphQL course. So here I have just a list of the things that we'll copy and paste. So let's start at the top and we'll just go one by one. Now first we need to go under the main.jsx. Let's close every file that we have. Inside the main.jsx, first we need to install or import the browser router, and then we're gonna wrap our application with it. Now let's import that. It is coming from React Router DOM. With the help of this, we'll have different pages that we could add. And then we also want to use this, let's see from the demo, this kind of grid background. And for this, we'll be creating a component. And I'll just say, we'll wrap our application with grid background. And that should be closed here. And now we'd like to create this component. Let's save this file. Our application will crash, but we'll fix it. I think we could delete the assets folder. We're not going to use it. And then here we'll just create the components. And then we're going to create a UI folder. And then we're going to have our pages. Okay, so if you take a look at the documentation again, they give you the code for this. Let's see. Okay, so this is the code. I just changed it a little bit, but it looks really, really similar. So let's go into the GitHub repo and copy this file. We're going to create it. Components under the UI will have grid background.jsx. So if you paste it, this basically use the background grid class to have that grid. And here we are getting a prop types error from ESLint. Let's just disable it. And if you don't know what prop types is, they basically say, just tell me what is going to be the type of this prop. And we don't want to just work with it for now. Let's say React prop types and just save it to be off. If we save, now we're going to get rid of that error. And if we save this one, we're going to import it. And in our application, now we have this grid background. And as our content gets larger and larger, it is just going to take the entire page. And let's see what's going to be the next step. We'd like to go under the app.jsx and initialize our routes. So instead of copying and pasting, let's just try to do it so that we could understand what's going to happen. So we have the routes component coming from React Router DOM, and then we have route component. One by one, we'll just get that. So when we visit the home route, we're going to render the homepage component, which we'll create. And then when we visit the login, we're gonna get the, let's say, login page. And same happens to the sign up page. When we visit the sign up, we're gonna get the sign up page. And then let's see what we have. When we visit a transaction specific page, we're gonna get the transaction page. And then we have the not found page. So I think I could copy this one and then just paste it. Okay, and then any other pages apart from these, we're gonna just show not found page. So let's say route path, and we'll just put an asterisk for this. That means catch all, and we'll say element not found page. And I think we're gonna start with the sign up page, and then login, and then I think transaction not found. So we'll just go step by step. Let's for now comment out these, and then this one. Okay, so let's save this file, and we're gonna go into the pages. Let's say you'd like to have the sign up page.jsx, and let's say give us the boilerplate. And most of you guys know that we have this package, React, maybe ES7 React, code snippets. If you install this, then you can just do RAFCE, and that's going to give you this starter code. And then you'd like to have the, let's say, homepage, and do the same thing. And then let's say you'd like to have the login page.jsx. Okay, save this file, and if you want to close it with your keyboard, it's Control W. And then let's see, you'd like to have the not found page.jsx. Okay, and lastly, we're gonna have the transaction page. And actually, instead of commenting out these, let's just Control Z and import all of them one by one. I'll just say import homepage from the pages, and then give us the homepage. And let's get these ones. So login page, the sign up page, transaction page, and then not found page. Okay, so let's save, and we're gonna visit. This is the home page, there you could see, and this is the login page, and let's say sign up page. And if we visit something other than those pages, we're gonna get not found page. And if we visit the transaction slash the transaction ID, just put something random, and here we could see all of our pages works. And the first thing that we'd like to build is gonna be the sign up page. Let's see, this is the demo application. So inside the sign up page, we have a form that has the full name, username, password, and radio buttons, and a button, and then a link that takes us back to the login page. And then for these, we'll be using input fields component that we'll create, and then for these, we'll be using a radio button component. And again, let's just try to do it from this documentation that I have created. And before that, let's try to add this header, and let's see what this header. I'll just try to log in. Okay, header is going to be this expense GQL title where we have all of our pages. So let's see, inside the home page, inside the transaction page, but not in the authentication pages. So in the login and sign up pages, we don't have it, and that's what we'll be doing. Let's go here. I'll just say for now const auth user. That's going to be hard-coded data for now. Let's say it is, let's say true. And above our routes, which means whatever you put here, you generally put your header component and then footer component here, and that means they are going to be in all of your pages. Okay, it's not going to be into any specific route. And we'll just say give us the header component, and we would like to create it under the components, and I think we could put it into the UI because it is shared. So let's say header.jsx, and we're going to go ahead and copy it and then just paste it. So if you take a look at this file, this basically has a title that takes you to the home page when you click to this GQL button or link, I'm sorry, and then we have a couple of different gradients that gives let's just log in. Okay, it gives this effect that you could see, and that's it. It's just Tailwind CSS, and again, I took this from this UI library that you could take a look. So we're gonna go ahead here, and I'll just say import the header, and we only want to show this. We'll say if auth user, so user is logged in, then render this component. Let's save, and here if we just take a look, we can see that it is working fine. But if we say user is not authenticated, then we're not gonna see that. And with that in mind, let's go ahead and build the sign up page. We're gonna copy this, and we'll just take a look at the code in a second. I'll just select all those and just paste it. Now it's about 100 lines of code, but if you take a look, there is nothing complex, where we have a state that puts the that holds the name, username, password, and then gender, and then we have the handle change, and this basically handles when you type something into the inputs, and when you submit this, we just console log our sign up data. And then let's see, we have Actually, let's save and let's see, but it is not going to work because we don't have the input fields. Let's create that and let's take a look at. Okay, copy this one and we'd like to create it under the components. I'll say input field.jsx, paste the code, and then radio button.jsx, and then just paste the code. Okay, so I'll copy this one and then just paste it. And inside the sign up page, we have the input field, which we already imported from the components, and then the radio button. Now, if you save and visit the sign up page, here we can see there is a title that says sign up and then a p tag that says join to keep track of your expenses, and then we have the full name, the username, password, and these radio buttons, and these are the input fields that we talked about. So let's take a look at the code. Just try to see that. We have input fields where we just pass the name, ID, label, value, and then on change, and we got this as a prop, and type by default will be text. But if you say type will be password for the password field, that's gonna take it and then add it into the input. And then we have label that is associated with it. So we say HTML4 for this ID and we pass the input ID. So when we click to the label, it's gonna open and just focus to that input, and it's gonna work for these as well. So this is super basic React code. I don't really think no one understands this, so everyone just knows what's going on here. And same for the radio buttons. Let's take a look at that component. They are just inputs. Okay, so just don't look at this class names. It looks really ugly, and it looks ugly just to give this effect when you click to it, so we could see it is customized. And yeah, that's gonna be it, where we have an SVG, a label, and then the input. It checks depending on the props, it should be checked or not. And when we submit this form, and let's see, at the end we had a button, I forgot to show that. So we have a sign up button that is type of submit, it is under the form, and at the end we have a link that takes us to the login page. And when we submit the form, let's see, we call this handle submit, where we'll just console log the sign up data. So I'll just open up my console and just zoom in a little bit, clear it, and I'll just say full name, the username, and then the password, and like the gender, and then click to it. Here we could see we got all those values, and later we'll just send this as a mutation to our GraphQL API. So that's gonna be it for the sign up page. I hope it was clear. Now we'd like to build the login page. That's gonna be relatively the same. Let's close all these pages and login page, paste it. Hopefully it should work, where we just import the input field. And again, we have a state handle change that takes the event target value and name and updates this state. And yeah, when you submit it, it just console logs it. So we are in the login page. Let's say this is what we have, and this is coming from the other render. So let's clear it. So we have the username and then the password. So that's gonna be it for the login and sign up pages. Now we'd like to add the transaction page. So I'll copy this and then just paste it. Let's see what components we have. I think we don't have anything. Let's go ahead and see the transaction page. And yeah, that's basically it. And when we say, so if user visits the transaction page, user will be authenticated, so they will be able to see the header component as well, and it's gonna be looking like this, where we have the transaction input, the payment type, which is either card or cash, the category is either one of them, and the amount, which is type of input, type of number, and then location, date, it has this type of input date, and then a button. Let's see the code for that. Starting from at the top, we have a state that holds all these fields, and then a submit button or submit function that console logs the data, and then the handle input change, that runs whenever you type or whenever you change one of these inputs. So we have this p tag that says update this transaction. We have this class that goes from this color via this color to pink 400, and it gives this kind of gradient look. And then we have one input for the transaction, and then we have the payment type. And you could see like it is really basic. We have a select tag and then two options with the value of card and cash. And so let's see, we have the category, again, three options. It's going to be either one of those. And then we have the amount, the location, and you could see like type is number for this, type is text for the location, and for the date, type is date, and it is just coming from native HTML. And then we have the submit button, and it is type of submit. Let's try to just submit this to see the data. So let's say this is salary. It is saving. We got it via card, and let's say it's this amount, and then we got the first day of the month, and let's say we got it in New York. So I'll just say update the transaction, and here we could see we have all these fields. So payment type is empty for some reason, and category as well. So okay, for now it is not working as expected, but we'll fix it. And the reason that it is not working is because of the default value. Let's see, so default value, it is form data.category, and it's because form data.category by default is empty. Okay, so this is something that we'll fix later. But for now, everything is working other than these two selects, okay? And again, we'll just fix it. So that's gonna be it for the transaction page. Let's see what we have next. We have the transaction form skeleton, and this is just for a loading state, just to show it for a second. Let's go under the components. We'll just say skeletons, and then what was the name? Transaction form skeleton.jsx. So create this file and then copy the content. And now we'll just have a loading state. If it is loading, then we'll return this. But for now, let's just return it immediately so that we could see. So it's gonna be looking like this when we have implemented the backend part. For now, just comment out this line. And then let's see what we'll have, the not found page. So I'll just close all these, and then not found page, I will paste it. Now we are using an image that is coming from public folder, and it is in SVG. Let's go ahead and create that. 404.svg. Oops, that should be lowercase. And I'll provide you this. You could just copy and paste it from the GitHub repo. So it's about, let's see, 250 lines of code. And it's basically, we'll just see what that is. Okay, so let's save this file. Now here it just gives us an ESLint error that says fix it, this single quote with one of these. If you just take one of those and replace it with this one, that's gonna work. But another solution is just wrap it with curly braces and string. Let's see the not found page. If we go into a page that doesn't exist, this is the not found page. Here we could see. And when you click the take me home button, that's going to take you to the home page. And that was the SVG that we have just created. Now the next step is to create the home page. And that's going to be the the complicated one. Let's go into the home page. Okay, so we need to get the transaction form, and we have a couple of chart data, or just one, but we'll take a look at that. For now, save this file and create this component called transaction form.jsx. And we'll copy this, paste it, where we just have, again, a couple of different fields. That is the transaction, payment type, basically the same form that we have. So if you want to, you could even make this reusable, but that would make a bit complicated for the tutorial. So for the sake of this video, I'll just skip it. So we have the amount, location, date, and submit button. And we have this handle submit. And instead of this time, instead of holding them into a state where we did in the, let's see, in the sign up page, and instead of having this handle change, this is a different approach. When we just submit it, we create a form data depending on this form and just console log it. And just to make this work, you need to add the name field to each of your input. So name is description for this one, and this is how we are able to get it. We say from the form data, get the description. And for the payment type, category, and rest of this, it is the same. You just give a name that is related to that input, and then you just say form data.get. So let's go into this. We already imported that, I guess. Okay, and then we need to get the cards, and let's see what that card is. So we are building the homepage now. This is the chart, this is the transaction form, and these are the cards. Let's go create that component. So we'll copy this, paste it. Now inside this component, we have a couple of different cards where the card type is either saving, expense, or investment. Let's create the card.jsx inside the components. Okay, this is the last component that we have, and finally it's gonna end. Okay, and we save this one. Let's visit the home page now in our application. If we refresh, hopefully it should work. And there we go. Now we have the chart, which we'll take a look in a second. We have the transaction form, and we have cards. Now we give this prop to the card, which is the card type. And depending on that prop, which is either saving, expense, or investment, we have a card class. So it goes from this color to this one, and background gradient to bottom right. So starting from that color until here, the color just changes. And now there is a trick here. Instead of doing an if-else statement, so if we didn't have this object, you would be doing something like this. So just comment out this. You would say let card class, and that would be an empty value. You would say if card type is equal to saving, then the card class would be equal to this class. And then you would say else if the card type is equal to expense, then you would get this class. So you would say card class would be equal to this, and in the else case, which is the investment, or you would say else if, and then you would put this class. Now instead of writing all these, we basically create a map. So I'll just delete all those. And now since card type, let's say it is saving, this is going to evaluate to saving, and when you pass it, that's going to return you this value, and that's going to be equal to the card class, and you just pass it. Now this is a really intelligent, or let's say smart movement that we could use. And if you want to add more categories after you complete this tutorial, you could add them into this object. So that's going to be it now. This is the logic for the cards, and in the homepage, what we do is this donut chart. And for this, we are using the chart.js. Let's take a look at the documentation for this. So you would visit the chart.js .org, and this is the package that we would be using, or the library. Let's say get started, or let's take a look at the examples. So under the chart types, here you could see there are lots of different charts that you could use, and they show you how you could use it. And the one that we'd like to use is this, I think, donut in one of the pie charts. Now they show you the setup as well, where they have a dataset, different props that you could take a look at from their API reference. Now this is the chart.js implementation, but there is also other package that we have installed. Let's say React chart.js, and this package is for specifically React, and that's what we have done. We have installed these two packages, and now they say import if you want to use this donut chart, import it, and then import the chart, rename it to chart.js, import these elements, and just use it. Now that's basically what we have done. You don't really need to memorize this or just know it by heart. This is something that you would copy and paste from the documentation. We have done all this configuration, and we need a chart data, which is an object. It has the labels. We have saving, expense, and investment, which are these labels that we have. Okay, expense, investment, saving, and when you hover over this, you still have that label that we could see. And then we have the data. So for the saving, it is 13%, and then for the expense, it is 8, and then for the investment is 3, and we put the label as this percentage string. So that we can see it is saving 13%. We could see that label, right? And that's basically it. These are some values that I have updated. If you put it, let's say cutout 100, it looks in this way. You could increment it, decrement it, and I think this value works fine. Then we have the border radius. If you say 10, let's see what's gonna happen. So nothing changes. Let's say 0. Okay, it doesn't have any border radius, but I think this looks a bit more clear or better. And then spacing, let's say if it is 0, then it's just gonna be like glued together, and I want to have some spacing. And then we have the border colors, and it should go in this exact same order that we have saving, expense, and investment. So I think that's gonna be it for the UI design part. Now we have copied and pasted a lot of code. Sorry about that, but just imagine if we were to type all these code like together from scratch. That would just take hours, if not days. And we don't want to waste that much time, but instead we just want to focus on the GraphQL. And after we complete this tutorial, feel free to just go ahead and update the UI however you would like to. So let's try to add a commit that says we have completed the UI design. Okay, we could see these are all the pages or components that we have added, and add all of them to the staging area. Now they are staged. Let's say UI design added, and then just commit this. And with this, now we have the backend and we have the UI design. Now the last part is just to put them together, and that's gonna be next. Okay, now we would like to connect from our React application to the backend GraphQL API that we have created. And for this, we'll be using Apollo client. Let's visit the documentation and let's try to see what is Apollo client. Even before that, let's take a look at the Apollo server that we have already created. We didn't really read the documentation, but I'll just give you a quick tour on this documentation. So they explain what is Apollo server, where it is the best way to build a production-ready self-documenting GraphQL API that can use data from any source. And in our case, the data source was the MongoDB. And then, so let's take a look. So there are a couple of different features that it provides, such as straightforward setup, incremental adoption, universal compatibility, and production readiness. So let's get started with the documentation. So again, this documentation is super clear. It just feels like a video tutorial where we just did the exact same thing. We have created a folder called the backend, then we cd into it, then we initialized a Node application, and then we set the type to be module in the package.json file so that we could use ES module, which was the import and export syntax. And then we were able to use top level await. Let's see in the index.js file. Now we are able to use await without any inside of the function. And it's because we have set this package JSON to be type of module. So that's what they are trying to tell. And then we have installed these packages, which was the Apollo server and the GraphQL. And I even put notes into our code base that says so what those packages doing. We already read that. And then so here they define the GraphQL schema, and a schema was consists of let's say the type defs and resolvers. So they have TypeScript and JavaScript version, and after that they have some hard-coded data, and that's what we have done. So it is that dummy data folder, and then they define a resolver. Again, that's what we have done. Then they create an instance of Apollo server, just like this, and they pass the type defs and resolvers. And this is like a basic usage where we just did actually the best way, right? We just merged them into one file so that our code base looks clean and scalable. And then they use this start standalone server, but instead we use the Express. And for that there were let's see, the Express API reference, and we follow that and just build it so that we could easily use the Passport.js and like all of the packages and features that we could get and benefit from Express. So that's basically it. And then we tested out even with this tool in our localhost. So that was the documentation. And after this, they just give you the next steps, which is really just reading the rest of the documentation. And then now we would like to go into the client and work with the Apollo client to be able to connect with this Apollo server that we have created. So they say Apollo client is a comprehensive, I'll just zoom in. It is a comprehensive state management library for JavaScript, and with the help of this, you could fetch the data, you could cache it, and modify the application data. And then it has a couple of different features, such as declarative data fetching. And with this, you have, so you don't need to manually track the loading states, error states, or the data. It all gives you, and we'll see that in a second. And then there are like excellent developer experience. This is really true. And then it designed for modern React, where we could use hooks and like incrementally adaptable, universally compatible, and other features. Then let's take a look at this one. Then they have the features. They just have a couple of different coding examples. Now this is declarative data fetching, where you just call this hook, use query, and then you put your query. In our case, it's going to be something like get transactions or get user, and it's going to give us the loading state, the error state, and then the data. And depending on that, we could just render related part of our application. Then it has, let's see, like local and remote data. And like they say, caching a graph is not an easy task, but they have spent years to solve this problem. And it is possible now. Just in one single line, you're able to cache in your Apollo client. And again, we'll just see that in action. Then you could just read the rest of it, but basically they show you how you could mutations, how you could create them with this GQL import that we'll use. So let's take a look at the actual get started guide, and we'll just try to do it step by step. Now they say install these dependencies, which we have done in our client. Let's take a look at the package.json. We have the GraphQL as well as the Apollo client. And now, after we done that, they say go into the main.jsx and import these. And that's what we'll be doing. Let's copy that. We'll go into the main.jsx and I'll just try to paste it. Now, we're not going to use the GQL here. They just try to show an example, a basic example, but we'll not do that. And we'll just make it actually our own examples. Then we need to copy this, okay, and just paste it, where we just say we have a client, which is Apollo client, and we pass our GraphQL endpoint. Let's say it's gonna be our backend application, HTTP localhost, and that was our port. And I think we were running that under the GraphQL. Let's see the route. Okay, it is exactly under this root route. We could make it in this way. Let's say that's going to be GraphQL. And if you don't know what that means, let's just see it quickly. Let's open up a new terminal. I'll just say npm run dev. Okay, it's gonna start that. And let's try to visit localhost 4000. Okay, so it tries to connect. Okay, this is our GraphQL API. It is running on this port and in this route. If we say that should be /GraphQL, and that's just preference that I would like to use it. And let's say it is running on this port just to have the correct log in the terminal. And now if we refresh, this is not going to work, but instead we'll just go ahead and say GraphQL. And that's this will be the endpoint that would like to send requests from our client. Okay, that was it. I'll say this is the URI that would like to connect. And after this cache, we also want to say credentials include, so that we could send our cookies alongside the request. So I'll just put a couple of comments so that you could have it. So this tells Apollo client to send cookies along with every request to the server. And then let's put this as well. Oops. Apollo client uses this cache to cache query results after fetching them, and this cache will be really good where we'll have optimized performance. And then I'll just put another comment, which is the URL of our GraphQL server, and in the deployment part, let's put a comment here. I'll just say to do so that we don't forget. I'll just say update the URI on production, because our application will not run on localhost when we deploy it. Okay, with that in mind, now in the documentation, if you just open that up, they say wrap your application with Apollo provider and then just pass the client into it. And that's what we'll be doing. Now with the help of it, we are able to use this client in our entire application. That's gonna be it for this file. Let's go into the front end where you'd like to create a, let's say under the front end. Okay, so I have already created the GraphQL folder, and inside the GraphQL, just create the mutations and queries. So I did that off camera and I forgot to show that. So create a GraphQL folder under the source, mutations and queries. In our queries, we're gonna have the user.query.js file, and then transaction.query.js, and same goes for the mutations, user.mutation.js, and then the transaction mutation.js. Now we're gonna put our queries and transactions. First, let's try to get the authenticated user query that we had in our backend, which was inside the user resolver, right? We had the auth user. It's gonna check if user is authenticated or not, and it's gonna return the user. So to be able to send a query, you could take a look at it from the documentation, or maybe let's just try to do it together. Okay, so this is an example. So they say this is just to showing purposes. This is not how we generally do, but instead let's go under the queries and execute a query. So that's how we would create it. So let's copy this now and paste it into the user query, and we'll just rename it to, let's say, get auth user, and we import this GQL from the Apollo client. Or maybe I'll just change the name to be get authenticated user, and then I'll say the query name, this could be anything. So I'll say get authenticated user, and now we are gonna send this query to this field. Oops, not this one. Let's close these. That was inside the user resolver. It's gonna be this query, right? We need to just send this exact query name. So we'll say auth user, and as the response back, we'd like to get the user ID, let's say, and then let's say username. And if you want to, you could get the name, profile, picture as well. Then let's say export this so that we could use it in other files. And then we're gonna go into the app.jsx. And now they show you have created the query. Now you need to call it, and we're going to call it with this use query hook. I will copy that and then just paste it, import that from the Apollo client where we'd like to get authenticated user, and this is going to give us an object. Let's say const. Okay, we're just gonna destructure the loading state, the data, and error if there are any. Let's try to console log the data, and I'll just say authenticated user. Now this is gonna be null because we don't have this. And let's see. Okay, we are not authenticated, so this should give us null, right? And let's go open up the terminal. I'll just refresh. So here we could see we have auth user returned as null, and initially it is null because it is loading. If you want to see that, let's say if loading, or maybe instead of returning for now, let's say console log the loading, and we'll just do the error if there are any. So when you just refresh, initially loading is true for a second and error is null, and then we got the authenticated user. Loading is false now and we don't have any errors. And next thing, let's try to add the sign up functionality. We're gonna go into the sign up page, and here we'll just say auth user. So I think we could delete this now, and we'll just say if data.auth user, and if you remember, that was the output we have in the console. So we got this object, we have the auth user field. It's because that's how we called our query. Oops, where was it? Okay, it's under this field. So data.auth user, if this is not empty, then show the header. But now since this is null, we are not gonna see this header in the sign up page. Let's see, or even in the home page. So we have some errors. Let's refresh again. Let's put a question mark because it is initially undefined. Okay, it is working and we don't have the header. Now we'd like to get this data and send it as a mutation to our GraphQL server, right? For this, we're gonna go into the mutations. I'll just shrink. So GraphQL, we would like to create a user mutation. So here I'll just say import the GQL from Apollo client, and then export const, I'll say sign up, and then call this GQL with template strings. And if you take a look at the documentation, you'll see they're using the mutation keyword, and then a name where I'll just say sign up. And this sign up mutation will take an input. So let's say $sign input, and the type of it was sign up input, if you remember from the backend part, where we had the full name, the username, and password, as well as the gender. Now this is how we called it. It was sign up like this, and then that's gonna take the input field, which is the input that will pass, and then we'll like to get the ID back, and then the name, and then the username. Now this looks a bit complicated, but you could name this however you would like to. If you say this is going to be X, then this should be X as well, but you can't really put this however you would like to. It should match with the type tabs you have. So inside user type tabs, you said sign up will be our mutation where we take the input. If this is input X, then this should be input X as well. Now I hope it makes sense, and we exported this. Now we'll go into the sign up page. Let's close this one and then this one. So here I'll just go ahead and say use mutation, which is coming from Apollo client. We will pass our sign up mutation that we just created. That's going to give us the const, but this doesn't return an object, where it returns an array, and we just destructure it. Let's say we have the sign up function, and then so this is the mutation function that you have. Okay, you could name this however you would like to. I'll just call it as sign up, And the second argument is the loading state and then the error state. We would like to use this loading state in the button. When we submit it, let's say it is going to be disabled if it is loading, and if it is loading, let's say it is going to say loading, but otherwise it's going to say sign up. Now in the handle submit, instead of doing this, we'll just prevent the default so that it doesn't refresh the page. And then in the try, maybe I'll just take this here, and then here inside the try we'll say await the sign up function. But now this sign up function was taking arguments, right? Where we'll just send the input, and it should be those fields that we have: the name, username, password, and gender. And that's how we would do it. It's gonna take an object with the variables, and then this is gonna be your actual variables, which is the input, and we could say it is gonna be the sign up data object, which is our state. And then for the catch, let's say console log it, and then we'll just show a toast. So if you don't know what a toast is, I'll just show you in the demo. So when we delete one of those, so we got this notification, and if it is success, we'll see this check mark, but if it is an error, then we'll just see a cross and the color will be red. So that's basically toast. And for this, we installed the package. So let's say import the toast from React hot toast. And to be able to use it, you need to go into the app.jsx and just put this component, which is the toaster. Okay, and now it should work fine, where if we have an error, we'll just show it. Let's save this, and inside our demo, and this is our application now. We don't have any sessions, any transactions, let's see, and we don't have any queries. We just have our database and everything is empty. Let's open up our console where we'll just try to log in or sign up. I'll say full name and password, let's say from 1 to 6. And I'll just say sign up. We have the loading state, and now I think we have signed up. Let's see the application. Here we have cookies, and we got the connect.session ID. And if we refresh now, we have the session that has been created for this user, where it ends with 51A. And let's see if we have that user, and there we go. This is Jando, this is his profile pic, gender, password, and it's his ID, which ends with 51A. Okay, it is working, it's great. Now what we'd like to do is when we send a mutation, once it's completed successfully, we would like to refetch a query, which is gonna be get the authenticated user. And we'll do this so that we could update our page. So now we signed up, but we are still in the sign up page. But instead, we would like to go into the home page. And for this, we need to update the app.jsx bit. Now here, when we visit the home page, we show the home page. That's great, but we only want to show this if user is authenticated. So I'll say data.auth user. If we have it, then take them back to the home page. But if this is not the case, they are not authenticated, then call the navigate to login page. Okay, that's gonna be it, and we'll just do the same thing for other ones. So I'll copy this part, paste it. We'll say if user is not authenticated, then they should be able to visit the login page. But if they're authenticated, then let's navigate them back to the home page. And same applies to this one. So I did something wrong. It should be inside this. Okay, I'll just save to get a bit formatting. If user is not authenticated, show them the sign up page, but else take them to the home page. And now we'll say if user is authenticated, they should be able to see the transaction page, but in the else case, take them back to the login page. And for the not found, we'll not add anything. So that's gonna be it. And now if we visit our application, I'll just refresh. So let's see. we have some errors. It says auth user cannot read properties of undefined. And we could say if it is loading, then let's return nothing. So now we got this error is because this auth user, data is null, and when it is null, you cannot say dot and something. You either need to add this question mark, which is optional chaining, or we could just say if loading, then don't show anything until we have data. And let's save. Okay, now if we try to visit the sign up page, we can't. We are in the login page. And if we visit the login page, we are in the home page. If we try to visit the login page, we cannot, because we protect our routes just like here. And then let's try to add the logout functionality. Then we're going to add that refetch logic. So under the user mutations, I will add another mutation. So export const logout. And again, we use this GQL string to pass our query or mutation. That's going to be our mutation, which is going to be a logout. And we'll like to call the logout, and that's going to return us a message back. If you remember, that's how we built in the backend part. That was the return type. We exported this, and then we'll export another one, which is going to be a login. While we're here, let's just add it. So mutation login, that's going to take the login input, and we're going to call the login mutation with this input, and we'd like to get the name, excuse me, the username, and then the ID field. Okay, I'll save this file, and let's go into the homepage. And by the way, we have an warning that says this is declared, but you never use this value. And I handle the error here, so that's why I think I'll just delete this. But if you want to, you could maybe take that error and just under the button, you would say if there are any errors, then just return a p tag that shows the error.message. I'll skip that. If you want to, you could just do it for the rest of our application. Okay, so we'll go into the homepage now. Let's see where we had the logout button. When we clicked it, we just say console log logging out, but we will update it now. So this is going to be an async function where we'll have the try catch, and in the catch we could console log, and then we should say toast.error error.message. We import the toast at the top. It is this one. Okay, and then for the try, now we would like to call the logout function, and we need to create it. Let's go and say use, I'll just give a bit space, use mutation. Then we're gonna call the logout mutation that we have just created, and that's gonna return us back this array where we have the logout function, then this loading and error state. And I'm not gonna use the error, so if you want to, you could. So we have the loading, and let's delete this loading, which is the hard-coded data. And if it is if loading is true, then we're gonna show a spinner that we have here with the class of animate spin. And I think that's gonna be it. But now I'll just put a comment here that I took from the documentation. So they say when you log out, most of the time you would like to clear the cache, and we'll do that so in a couple of minutes or seconds. Let's save this, and that should work fine. But now we have another problem. When I click to this, I would like to log out and then go back to the login page, but this is not gonna happen, and we're gonna fix it. So I'll just open up the console, and under the application, under the cookies, when I click to this, now we have the loading state, and it says request is not defined, which is coming from our backend. Let's go ahead and fix it. Inside the resolvers, user resolver, where we have the mutations, the logout, now it says request. Yep, that's correct. So let's say context.request. Okay, that should be fine. Let's try to log out again. We have the loading state. Now it says response is not defined. Let's say context.response. Let's send another one. Hopefully it should work now. And there we go. Now that cookie has been removed. And inside the session store, let's see, we don't have any sessions, and it is working fine. But now it didn't take us to the login page. If I refresh, then it's going to take me to the login page. And to be able to solve this, we use something called refetch. So the second object or the second argument, you say refetch queries, and the query that you'd like to fetch will be the get authenticated user. Let's pass it like this. So this is the name that we have created in this query, right? It should match. And now let's try to sign up with another account, and we should add the same thing for this one. When we sign up, after the mutation, we'll pass the second object and we'll say refetch queries and get the authenticated user. So it is gonna sign up the user and it's gonna run this query as well. And in our application, we will see, okay, user was on the sign up page, but now they have authenticated, and this value, it is true because user is authenticated. Then it is gonna navigate user to the home page. I hope it makes sense, but let's see that in practice. I'll refresh and I'll just log in as Jane Doe. So it's female and password from 1 to 6. And let's sign up. Here we have the connect sit, and now we have been redirected to the home page automatically. And let's refresh. We should have the session. Okay, everything is working as fine. And if we log out, that should take us to the login page. And there we go. We don't have the cookie. It's been removed. So basically that's how we would use it. Feel free to check out the documentation where you have the mutations, and let's see if they show like refetch. I'll say Control F, refetch. Okay, refetching queries, that's how you would do it. You could either get the get the name as exported variable, or you could put it into a string just like we did. And there is another solution for this. So either you refetch the query when you add the mutation, or you could update the cache directly. Now this is also fine, but it's a bit more complicated. So we need to write this much of code, which I think it is just gonna make the tutorial a bit more complicated, but this is absolutely fine, where we just send one extra fetch requests. And if your application gets like really large, you have active 1 million users monthly, then instead of refetching, you could use the updating the cache so that you don't send one extra request for each user. Okay, so with that in mind, let's try to add the login functionality, where we're gonna go into the login page. And before we get there, so we have created the login mutation, just keep that in mind. And we could see inside the login, we take the input, we authenticate the user, and just send the user back to the client. And so yeah, that's gonna be it. Let's go into the login page and we're gonna get the exact same thing. So I'll say use mutation, where we'll just pass the login. It doesn't give us for some reason. We didn't export this maybe. User mutation, export cons. Okay, so let's get it manually. Import login. Oops. Okay, get the login from the user mutation file. Then we passed it. Now we'll say give us the login function. So const array login, and then the loading as well as the error state, but I'm not gonna get that. And then inside the login, we'll just have the refetch queries. Once we log in, we'd like to get the authenticated user query once more, and we'd like to use the loading state for the button. Where is it? This button, and we'll just say disabled loading. And here you could see I have a class that says when it is disabled, just change the opacity and cursor shouldn't be allowed. Okay, and we could change the text. If it is loading, let's say loading, otherwise that should be login. I think that's gonna be it for now, but we need to update the handle submit as well. Oops. Okay, we just added this one, and then I'll just say async. That should be try catch. In the catch, let's say toast.error, error the message, and then we could say console log error logging in, and in the try await. login, then we need to pass the variables, which is the input. That's going to be the login data object that we have, which is the username and password. Okay, this code base now reads like an English sentence. We're going to go in, I just refresh. I'll say I would like to log in. If I put the wrong password, I'll just put 123. Let's log in. It says invalid username or password. That's what we have handled in our backend. And if I put or let's say if I just leave it as empty, that's gonna say again invalid username. Maybe we could update it and just say here if login date, if username and password are empty, we could just say return out of this function and just say toast.error, please fill all the fields. Okay, so that's what we got. And you could add the same logic to the backend inside the login function. Now we'll go and say password from 1 to 6. And if we log in, there we go. And let's actually add this logic to the backend as well. So it is really important. You don't really want to only handle the errors on the client, but you also want to check for this in the backend. Inside the resolvers where we had the login, we'll just say if username or password are empty, then let's say all fields are required. Now, even if we delete this part, okay, or I'll just comment this out. So let's try to log in again. If I leave this empty, it's gonna say all fields are required, and this is coming from the backend. Okay, just to keep that in mind, I'll just add it. Now we know how to do it for the sign up function and for other places as well. I'll just leave it as a challenge. Okay, we have the login functionality, logout, and sign up. Now the next thing, I think we'd like to just create a transaction, and then we will fetch transactions, then update, and then delete. So let's start with the create transaction. And even before we get started, maybe we could add a commit where we just say, let's add all of them. And then I'll just say authentication. So authentication handled on client. Let's say on the client. And then I'll just commit this. Okay, so we would like to create a transaction. For this, we're going to go into the GraphQL mutations, where we have the transaction mutation. Let's get the GQL from Apollo client. And then we're going to say export const create transaction. And then we'll just open up this GQL template strings. And then we're going to have the mutation. Let's call it as create transaction, which is going to take an input, which is the type of transaction input. And if you remember, that has things like description, payment type, location, category, and that kind of stuff. Now we'll just say the one that we have created, or name it, was the create transaction. That was our mutation. We'll say input, and then just pass the input that we got. Then as the response back, we'd like to get the ID field, the description, let's say. Then we had the payment type. Then we had category. And then amount, location, and then the date. So that's going to be our create transaction mutation. And while we're here, let's actually create the update transaction as well. So not the delete one, let's say update transaction. And that's mostly going to be the same. The mutation will say first, then mutation name, where we'll just take an input, type of transaction input, or then the one that we have created in the backend. I just realized, let's go into the type tabs. Create transaction was taking this create transaction input, and the update transaction was taking the update transaction input. So let's use it. Copilot tried to cheat me and he was successful. So I'll copy this and then paste it. These are the inputs that we need. And then we'll say update transaction, and this is the name. I just want to just re-mention this again. It should match with this one, and then this one, and then this one, right? And this input field should also match the one that will just pass it. So this one, it should match with it. And then input that we'd like to get, Then we'd like to get the exact same fields. I'll auto accept that. And lastly, we'd like to delete a transaction, which we're taking the transaction ID. So export const delete transaction. Then I'll just auto accept this. And okay, so we delete the transaction, which takes the transaction ID. And instead of getting all these values, I think we could just get the ID because we are not going to use any of them in our client. So yeah, that's gonna be it, I think. If you want to, you could keep it. Now we have all of our mutations. Let's go into the which component is gonna be the transaction form. So I'll just shrink this so that it doesn't get annoying. Components, transaction form. Now this is, for now, just when we submit this, we got the transaction data in our console, but we'll fix it. Let's say we would like to use mutation hook and then create transaction mutation. Then we're gonna refetch, but not now. So const, let's say create transaction. That's gonna be our mutation. And then we're gonna get the loading and error states. So in the button, I'll just say disabled, should be a loading depending on this state, and then either loading or add transaction text. When we go ahead and submit that, I'll just cut it for a second and I'll say try catch. So inside the try, or maybe before the try, I'll just paste this transaction data that we got, and then in the try we'll say const data, and we'll say await create transaction mutation that we got, and that's gonna return us the data. And we just got this to be able to console log it, or maybe we could delete this for now. Okay, so here we'll just say this will take the variables, which is the input, which is the transaction data, right? And then once we've done this, we would like to reset the form. I'll say form dot reset. And then lastly, we'll just say toast dot success. Okay, this is getting a bit annoying, but import toast from React.toast. So toast.success, we could just say transaction added successfully, and maybe let's say created. And in the catch case, I'll just say toast.error and just maybe show the error.message. Okay, so let's see what we're doing. Just quickly reiterate. We have the handle submit. When we press this button, this will run, where we got the description, payment, and the rest of the form data. We're going to send it into our mutation as the variables, which is the input. And we send our state. Let's see, the transaction data. It is not a state, but this object that we created. And then we will reset the form and just show a toast. Let's test it out and hopefully it should work. Now I'll clear those and I'll say I got my salary. It was payment type was card, and then it was a saving. Let's select it, and amount, let's see, it was about $2,000, and I just got it in the first day of the month, and the location was New York. So I'll add the transaction. We have the loading state and it says transaction created successfully. Let's double check in our database. Inside the transaction, we should have that transaction, and there we go. Now we'll just test something. So I'll just say I bought an AirPods, and I'll just say it was an expense, but I didn't change this part. So let's see if it is gonna work as the default value. I'll just say it was $500. I just bought it yesterday, and we could leave the location empty because it wasn't required, right? I'll just say add transaction. Here we go, transaction created. Let's check in our database if this field stayed as card. Okay, we got the AirPods, payment type is card, category is expense. Okay, it is working. And the reason is when we copied and paste the code for that select, we say, so do we have the default value? Okay, we don't. So I'm just trying to make sure this is working as expected. I'll just say console log the transaction data. So now when we submit this, it's not going to be created in the database, but this is just for testing purposes. So I'll use salary and I'll say 200, just put some random data and add the transaction. Now we got the category is saving, okay, and then the payment is card and the rest of it is working. Okay, so I just want to double check so that we don't have any errors. So it just gets the default value in that inputs. And now that we have created the transaction, let's try to query them and get those transactions. And maybe we could add a to-do here, and I'll just say refetch once you create the transaction. And we'll do that. I'm just putting this so that we don't forget. So let's go into the GraphQL queries transaction query, where we'll just try to get the transactions. So I'll say export const get transactions, import the GQL, where I'll just say query get transactions, and the name was transactions, and you'd like to get those fields. Inside the, let's refresh this, and inside the, let's save this, and inside the home page, where we have the cards, let's go into the cards, and we'd like to fetch them. So I'll say use query and pass the get transactions, which is going to give us the data, the loading, and then the error. And I'm not going to use the error. If you'd like to, you could. So you maybe would get the error, and you would say if there is any errors, just say error.message. And for the loading, you could show a loading skeleton. You could create it under this folder. So I'll just keep it simple and actually try to render the data. And for now, let's say console log the data. I'll just say maybe what was it? So I'll just say cards, which is our transactions. So I'll just say data, and let's save. In our console, we should be able to see it. We have cards, which is an array of transactions, and yeah, there we go. We have one transaction that we have created, that was the saving, and then we have the expense. Now date is being created in this timestamp, and we're gonna take it and convert it to look like this kind of value. Now that we have our transactions, I think we are ready to just render them in this history part. So for this, I'll go and maybe we could remove those for now, and I think I'll just delete all of them, and then I'll say if it is not loading, and if data dot, let's say transactions dot map, and then we'll just get the each transaction. And here I'll just like to delete the loading state, not from here but from here, because I don't want to show a p tag that says loading. Okay, I'll just delete those, and as I said, if you would like to handle those cases, feel free to do it. It's pretty simple. And then I'll just say transaction. For each transaction, we would like to render the card component, where we'll pass the key as a transaction._id, and then we will pass the transaction. Now later we will change this logic here a little bit, and the reason that I would like to show you the relationship, so I'll just put a to-do comment. So we will add the relationships for this part, and then for another part of our application, so that you could learn the relationships from this tutorial. And for now, that should be fine. And I'll just paste one line after this div, where I'll just say if it is not loading, and if data.transactions.length is 0, okay, if this is the case, then we'll just say no transaction history found. And if we go into our demo, that's what we'll have. I'll just delete this one. Now we only have one expense and UI updated. Let's delete this one as well. Okay, now it says no transaction history found. It's because loading is, so it is not loading, and there is 0. So this array is empty. Then it says no transaction history found. Okay, we're gonna save this, and inside the card component, we would like to get the transaction. So we have destructure this and we're gonna get the transaction, and depending on this value we will render these parts. Now here what I'll be doing, I'll just say let, and from the transaction, so from the transaction we're going to destructure a couple of different fields, which are gonna be the category, and then the amount, the allocation, the data, the date, the payment type, and then the description. So these were the fields that we had inside the transaction. Now why did we call this as let is because we're going to change a couple of fields. I'll just say description. Let's start with it. We'll just say description. Now for the description, if user puts something like salary, we would like to take the first value and uppercase it when we render it. So I'll just say salary, and it was a saving. I'll just put some random value. This is the demo application that it's working, and I'll just add it. Now, even though we have added salary in the lowercase, right? We said that it's going to be looking like this, but here it has been capitalized. So that's what we are trying to do. So we'll just say description, get the first character, just take it to uppercase, and then just take the rest of the values as they are. And then we'll do the same thing for the category, where I'll just copy it and paste it. We got the first value and uppercase it, and then slice the rest of it. Let's just put this optional chaining so that we don't have any errors. And then inside the utils, let's see where it was. Under the source, we had the utils. I'll create a file called format date, which is a function that I took from the ChatGPT. And it is not something that you would like to memorize, but rather we pass a timestamp and it returns us this kind of format where it says February 1st and then the year. This is how we're going to be using it. Let's go and I'll just say formatted date. So const formatted date, and we'll call that format date function from the utils, and we'll just pass the date. Now it says the card type does not exist, so we'll just say the category it was, right? We have the category in our transactions. And then for the payment type, I think we'll just use it as they are. So this is the saving, which is the category, right? I'll just say category. And then we have the description. Then we have the payment type, the amount. So we have the dollar as the string, and then the amount value that is coming from the database. And then for the location, now since location was so optional, we'll just say either we'll just put the location. If it is empty, we'll just say not available. And then we're gonna put the date, where I'll just say formatted date. And for the source, we're gonna put the user profile pic, but more on that later, I think. Let's save and hopefully it should work. Let's go and I'll just refresh. Okay, there we go, but we have an error that background doesn't work. So we have the card class, we said this is gonna be the category. So we have uppercase the category, right? And it is not matching with this one. So if we take this and put it above, it should work. So the problem that we had was we took the category, let's say it was saving, and then we make it look like this. Now it wasn't matching with these ones, so we would get undefined instead of these values. So if we put this above the category, then it should work. Okay, we have a saving, we have an expense, and let's try to add an investment. I'll just say Bitcoin. It was card. Let's say I bought it about $1,000, and I just bought it last week. I bought it, let's say, online. And I'll add the transaction. There we go. It's been added. Now what we would like to do when we add a transaction, we could call the refetch as we have put a to do. So let's say refetch queries get the transactions. Now, if we refresh, we have this investment. Let's try to add another one. I'll just say I got new salary. It was about $500. I got it last week. And if I add that now, it should update this part. There we go. Transaction created, and it refetched these transactions. And that's how it works. And for this chart data, we'll just, I think, leave it at the very end because it's going to be a little bit more involved and complicated. But for now, I think we could move on with the delete function. And let's see if we have any to-dos. So we say refetch once you create the transaction. We have completed this, but I'll just put another to-do. Here we need to, when we add the relationships, we're going to change this logic. So when relationships are added, change the logic a bit, or not the logic, but we'll just change the refetch query. So for now, don't worry about this. It is just a note for me. Okay, for now, let's just go ahead and delete the transaction. So we already have the delete transaction here where we have the button, right? So I'll just add an event listener for this. Okay, we are not in the transaction form, but in the card. We have that. Let's see. We have the trash icon. I'll just say on click to this. We would like to call handle delete function. Create this. It's going to be an async function where we'll have a try catch, and let's import the toast at the very top. It is coming from React.toast, and we'll like to call our query, or actually the mutation. So I'll say use mutation, where we'll just pass the delete transaction, and here we'll take the delete transaction mutation, then a loading state, and once we delete this, we'll like to refetch a query, which is the get transactions, so that it's going to update our UI immediately. Let's add the loading state to our button, or I think we could skip it, or if you want to, you could add it where we just did in the previous parts. You would just say if it is loading. So for this, let's say if it is not loading, then show this trash icon. Let's say if it is loading, then just show this animate spin. And maybe we could save it for now, and let's see how that will look like. And then in the try, we'll just say await deleted transaction, where we would like to pass the transaction ID. So transaction ID, and it is going to be the ID of the transaction. And we could say transaction deleted successfully in the catch, error.message. And for debugging purposes, you could say, maybe you could put it in the console, or we already have it in the toast. So yeah, that's gonna be it. Let's try to test it out. If I delete this one, we have that loading spinner for a second, and it says transaction deleted successfully. But let's say, just to test it out, I'll say this is false and this is true, and how that looks like. Okay, maybe it has a bit too much margin. Margin X, let's just say 1. Or maybe even delete the margin completely because we have a gap inside this flex. Okay, it is working fine now. I'll just say if this is not loading, show that trash icon. If it is loading, then show this icon. Okay, that's gonna be it for this one as well. So the next thing that we'd like to do, I think, will be the update transaction. When we click one of them, that's gonna take us to the transaction page. And for now, it has this hard-coded value. Let's fix it. When we click to it, where is it? It should be here, where we just say take us to this ID, but instead I'll just delete it. So we would like to go into the transaction page / and then the transaction underscore ID. Let's save. Go to the home page. If I click to this one, it's gonna take me to that page. And if I click to this one, it's gonna take me to this transaction page. And here we're gonna fetch that data first. Just put the default values to these inputs, and then when we update one of those fields, we will click the update transaction button and it's gonna just update it. Now the first thing that you'd like to do in this page, when we first visit it, we would like to fetch this transaction from this ID, which is coming from the params. And let's go into the transaction page. I think we could close these. Now we have the error we're not using, so I'll just delete it. And then let's close all these. And then inside the pages transaction page, we would like to get the ID from the params. I'll go at the very top and I'll say const ID and then use params, which should be coming from React Router DOM. Okay, so let's first console log it. So I'll just say console log the ID. And in the console, we see that this is the ID of this transaction. And we call this as ID is because inside the app.jsx, we set that transaction/ID. If this was hello, then this should also be hello, okay? Let's actually test it out to see if that works. Save this now and save this. So under the ID field, we called it as ID, but let's say hello. So here we could see it's just working fine. It's because that's how we called it. Let's say ID back. Okay, we got the point now. And next thing that we'd like to do, just get only one transaction for this page. And let's try to create the query for this. I'll say export const get transaction. And then this will need a variable. Let's say query get transaction, and let's see if it was, okay, it was the transaction. Was it the ID or the transaction ID? How did we call it? I would like to see in my type defs. So that was actually the transaction ID. That's what it'll be. And then we're gonna pass this ID. Then that should give us all these fields that we had previously, like ID, description, and these. Let's save. Here, use query get the transaction, where we want to pass variables. And then that's gonna be the ID field, like this. Or maybe that's gonna be the transaction ID. And then we'll take the ID from the params. That's gonna give us an object where we have the loading state, the data, and then the error state, which I'll not use. So let's try to console log the transaction data. And we have a couple of different console logs. Let's just try to delete all of them. And we're not using error. Oops. I'll just refresh. So here it says transaction data undefined. And let's see why that is. Okay, the problem that we have, this shouldn't be the transaction ID, but it should be the ID. Let's say it's because it is ID. Here we said we're gonna get it as an ID. So this should match with the variable name that we have, that we are sending. That was my bad. Now let's try to save and see that. There we go. We have the transaction, which we have all the fields that we need. And then we'd like to get them. Now we already got it. Oops. Okay, so when we refresh this page, we automatically want to have the description, the payment type, all these fields for this exact transaction. And for this, we're gonna go into here, and we're not gonna say it should be an empty string initially, but we will say it should actually be data if we have it. So data.transaction dot description. If this is empty, then it could be an empty string. So basically we have the initial value, or we're gonna have the empty string. Okay, so let's do the same thing for these ones. Okay, if we save this, now it is not gonna work, and I'll just tell you why. Let's refresh. Now it doesn't work. When you refresh this page or you come from the home page, Okay, when you come from the home page, it works, but if you try to just refresh this page, it doesn't work. So the reason is, when you first try to load this is empty, so it takes this value, but then you have the data, but this component doesn't re-renders. So we're gonna go and just run a use effect for this. So use effect, and our dependency array will be the data. When it changes, this use effect should run. We'll say if there is data, we'll just like to set this state. So set form data with these values. I hope it should make sense. Now we could delete those because we already have the data. So I'll say Control D and delete them. Okay. Now, even if we refresh this page, we should have them as the default value. But now we don't have the date. It doesn't working even though we set it. So the reason is we get this date as a timestamp that we have in our database. So date, so it doesn't look like right here, but we take a look at from the console, date looks like a timestamp, just like this. And we can't pass it into an input date. And for this, the one solution that I found is, I'll just copy and paste it, where you just wrap this inside the new date constructor, and you say transaction.date, you convert it to a number. By default, this is string, and you run this method as well as the substring. Now let's save. Hopefully it should work. There we go. I'll just refresh the page, and we got this date and it is working fine. And let's try to do the same thing for the one that we have above, or maybe we don't need it. Okay, now I hope it makes sense. I'll just try to quickly reiterate. So we run the use query to get this transaction, and we pass the variable from the params. We said that the variable will be ID because that's how we are getting it in this query. And then we have the form data. By default, it was an empty string, but we just backed it with this data value, and it didn't work initially is because when we fetch this, it doesn't re-render our component. Let's say not re-rendered, but it didn't re-evaluate this use state value. And that's why we just run a use effect that says if there is data, then just update this part with the form data so that we could get it. And here we have the value, which is form data.description, and then default value for all those inputs, and it is working fine. Now in this page, what we'd like to do, when we click to this update transaction, it should call our mutation and just make it work. Let's go ahead and create that mutation. I'll just say use mutation, and we'll pass the update transaction, where we'll just say it's going to give us the update transaction, and then the loading state. Here we need to pass, okay, now we have two loading states. Let's say updating transaction, and then, but that should be loading, right? Loading, and then we're going to rename it. So that's how we would do it. I'll say update, or maybe loading update. And then inside the handle submit, we'll just have a try catch. And in the try, let's just try to actually call our mutation. So update transaction, where it's going to take an object, and that's going to be our variables. And our variables are the input. So I'll say input field, and we would like to just spread our form data. So it's going to be category, description, location, all these values that you could see here. And we can't really pass the amount as it is, because by default it is string, and it's because it is coming from the inputs that we have here. Okay, so input gives you the value as string even though it is type of number. So we need to convert it to number, and I'll just say, before we try, let's say const amount, and I'll just say parse float form data.amount. So I'll just put a comment, convert amount to number, because by default it is string, and the reason is it is coming from an input. That's how it works in HTML. So we'll just say amount, and then we also need to pass the transaction ID so that we know which transaction that we are updating. And we got this ID from the params. It is this one. And with this now, it should be working fine. We'll just say toast success transaction updated successfully. And if we have any errors, we'll just say toast.error failed to update the transaction. Or I just want to say, just show me the error message that is coming from the backend. I think with this should be working fine. We'll use this loading state for the button when we say the disabled field, well, depending on this loading update state, and then we'll say it is updating or update the transaction. And we are not using this loading state. For this, we have created a skeleton. Let's see, I think we have the code that is commented out. If it is loading, then show us the transaction form skeleton. Let's import it. Import transaction form skeleton, and from this file. Okay, that's gonna be it for this file. Now this looks a bit giant, but there isn't too much going on. We just have like 200 lines of HTML and just maybe 60 lines of like logic, which are the states. We have a use effect, and we just have the mutation in the query. Let's test it out. I'll just refresh. Now we have the salary, and did you notice that loading state? Like we have a loading state for a second. Now this was a salary saving of $2,000. I'll just say it was actually 2,500, and the date, let's make it just today. And let's update the transaction. There we go. We had the updating state and transaction updated. When we go into the home page, inside the saving, here we could see it has been updated. Let's refresh, and we got that value. Now, if I try to update this again, where I'll just say value should be this and update it, I'll go into the home page. It's been updated. And also, let's see the caching in action. Now I'll just refresh this page and open up my console. I'll go into the network. Maybe I'll just zoom out a little bit, or maybe I'll just zoom in. Okay, so now I'll just refresh this page. Maybe we should go with the fetch XHR, and I'll just refresh. Now we have two different queries: to get authenticated user and then the get transactions. And now I'd like to just visit this transaction. When I click to this, it has another request where it got this transaction. But if I go back to the home page, we don't send another transaction to get all transactions. It is because they are being cached, and this makes it super fast for the subsequent requests. Now, if I visit this one, it is not going to have any loading state, and it is not going to send another request because it is being cached. I'll click to this. There you go, it is immediately on this page. We don't have anything. But if I try to visit this one or this one, it should send a request because we haven't cached them yet. So I'll just click to this. We got a request, we had the loading state. But now if I visit this one again, there will not be any network requests or any loading states. And if we visit this one, we again should have loading state and then the network requests. So you got the point. But if we go into the home page, it just works as expected. It doesn't send another request to our backend. So yeah, that was the caching. And if you want to explore more, read the documentation and just open up this network, fetch XHR, and just see how that works. You could see the preview, the response, and if you have any errors, that'll be displayed here as well, where you could take a look at the stack trace and just explore it. Now we are able to create a transaction, delete a transaction, and update a transaction. Let's make it a type of investment, and let's say this was cash, where we bought an AirPods, and let's say update the transaction. Let's go to the home page. Here we could see it's been updated and it is working fine. So for the payment type, we could also try to capitalize it inside the card.jsx, where we have the payment type. I'll just duplicate this and then just rename it to be like this. And let's say capitalize the first letter of the description. Okay, like this. Now let's see they are being capitalized as well. And this is how we use GraphQL both in the client and in the backend. So we use the Apollo client to just do some CRUD operations. Now the next thing that we'd like to add will be this category statistic data, where we could change this hard-coded data with the actual data. And then lastly, we would like to add some relationships so that we could learn them in this video as well. So let's take a look at how many to-dos we have. So we have one to-do for relationship in the transaction form, and then in the card, we're going to update this in the production. Then we need to add the category statistics in our backend and in our resolver, and we'll just add another relationship. Okay, for now, let's just try to add all of them to the staging area, where I'll just add it and I'll just say CRUD operations, let's say CRUD added or I'll just say CRUD added in client. I'll just commit it. Okay, so we have committed our changes, and now we'll like to go into the home page. There is a problem that we need to fix. And if you want to navigate from the files, you could just press Ctrl E or Ctrl P, then you just type the file name and then just visit. Now, the one problem that we have is about caching, and we said that in the documentation, they say clear the Apollo client cache in some scenarios. Let's visit and see what are those scenarios. Now, they say sometimes you might want to reset the cache entirely, such as when a user logs out. Currently, we don't really clear the cache when we log out. And to be able to do it, you need to call this function called client reset store. So let's see if we don't do this, what's going to happen. Now in our application, we don't have any transactions. I just deleted all of them from the database. Now this is the account of, let's say, Jane, where I'll just try to log in and I'll say salary of Jane, and I'll just put some random values, create a transaction for Jane. Okay, so we're gonna log out. We have the salary of Jane for account of Jane. And if we try to log in as John, we shouldn't be see any transactions because John doesn't have any transactions in his account. But if we log in, we still see there is a transaction, which is the transaction of Jane. And it is because when we log out, we didn't clear the cache. And for the performance reasons, Apollo client uses cache, as we talked about it previously, and it is not going to clear the cache. You need to force it to clear the cache, and that's what they say. They say when a user logs out, just try to reset the store so that you don't have any problems. But if we refresh this page, now that's going to be gone because when you visit the page for the first time, the cache will be empty. And we could now fix this if we say client, which we need to get it from here, from the mutation. Let's say client dot reset store. Okay, I think we could also put await, but let's not put it because they don't, as far as I can see from here. And then let's save this file and just test it out if it is gonna work or not. I'll refresh this page and I'll say salary of John because this is the account of John. I'll say $200. Just put a date and add the transaction. Let's log out. Cache should be cleared. Would like to go visit the account of Jane, and she should have her own transaction. And there we can see it has been updated. It says salary of Jane and not the John. So that was the first issue that we have fixed. Now the other one is not really an issue, but rather it's a to-do. We would like to go into the backend, resolvers, transaction resolver, and then inside the queries, we said that we would like to add category statistics query so that we'll be able to get some data for this chart. And for this, let's go into this resolver we'll just try to add it. So I'll just copy this name and then delete this line, and I'll say category statistics. That's going to be an async function. We're going to skip the parent and then the args, but we're going to be using the context. And inside, let's create, first we should check if user is authenticated or not. If user is empty, we'll just say unauthorized. And then let's try to get the user ID. So I'll say const user ID, from the context, get the user, and then underscore ID. Then we would like to get the transactions for this user. I'll say await, from the transaction model, find every transaction that has this user ID. And then now we'll just try to manipulate this data for our needs. And let's try to complete this function, and I'll try to explain with an example. So let's say const category map, which is going to be an empty map for now, or an object. Then we would like to run a for each. I'll say transactions dot for each transaction, run this function, where first we'll say if category map dot this transaction category does not exist, then we're gonna initialize it with the value of 0. And if this is not the case, if this category exists in our category map, then we'll just try to increment it by the amount. And again, this is gonna make sense in a second. I'll just give an example. Then after this for each, I think, yeah, after this, we'll just say return object dot entries, which is used to convert an object to an array. Then we'll pass the category map, which is our object. Then now that we have an array, right, this will take the object and convert it an array. And we could use the array map method, where we could destructure the values, which is going to be the category and then the amount. And we're basically going to return it inside an object. Now let's see what we have done, why this code looks super complicated. Okay, let's save, and I'll just paste some code, some examples I mean. Let's say we have these transactions in our database. We have 2 expenses, we have 1 investment and 2 saving. The amount of expenses in total is 50 and 75, which makes 125, right? And then we have 1 investment for $100, and then 2 saving. In total, they make 50. So we have this in our database, just imagine. Then we're gonna run this for each so that we could convert this data into an object that looks like this. So we took the category map, we initialize it, then we said that now we have expense as amount of their total, which is 125. And then for the investment, we have 100. Then for the saving, we have 50. Okay, we have the object, but now we need to return an array for this data to work. Let's go to the homepage and see. So here, this data wants us to have some array, right? And that's why we'd like to just manipulate it and send it. And when we run this return object entries on this category map, we're gonna get this output. I will paste it. Okay, this evaluates to this return value that you see here. We took this object, which has expense, investment, and saving, and we just converted into array of objects, which we have 3. So 1 expense, 1 category, and 1 saving categories. Then we have total amount for each of them. I hope now it makes sense. Just please pause the video, take a look at the code and what I have explained. It should be clear at this point. Now we could save this file, and then we need to add this category statistics query into our type defs as well. Inside the transaction type def, here we have a to-do. Let's say category statistics, where we'll just return an array of category statistics. And let's try to create this type. I'll just go ahead under this type of mutation. I'll say type category statistics, where we are returning an array of category and total amount, right? So category, that's going to be type of string, and is it amount or total amount? So here we could see it is total amount, so we'll just say total amount, and that's going to be type of float. Okay, we have this in our resolvers and type defs. Let's go into the front end, the GraphQL. In the queries, transaction query, where I'll just export another query. Export const get transaction statistics. So I'll just say get transaction underscore statistics, GQL, and then, oops. Then I'll just say query get transaction statistics, and then we'll just run that. We'd like to get the category and total amount fields. Inside the home page, or in the home page, we'll just run a query. I'll say const, and before that, let's say use query, and then pass our transaction statistics, import it. Then that's gonna give us data, loading, and then the error state, which we don't really want to use. And let's delete the loading for now, and I'll just say console log category statistics, and then just return the data. Let's see in the console, hopefully we should get the data that we'd like to have. Let's refresh. So category statistics, here we go. We have one array of objects, which we have only one object, is because we only have one transaction. So we got, oops, so we are looking to the wrong part. So category statistics, it looks like undefined. Okay, let's see what is the reason. We have the get transactions, we set category statistics. Okay, this is the name, right? We set category statistics. We have the total amount, and maybe inside the transaction resolver in the backend. So I think I found the issue where instead of returning the amount, let's just say it's gonna be the total amount. And let's rename this to this one as well. And that should be working fine. Let's try to refresh. And there we go. Now we have the category statistics, which we have just one object that says you have one saving, and this is the total amount. Let's add an expense. I'll say I spent $200 and I bought AirPods. Add the transaction. Now let's refresh. Now we have two different statistics. We got one saving, this is the amount that we're gonna show it under here, and then we have an expense that will also show it and just display it here as well. Then let's add an investment. I'll just say I have spent most of my money on my investment. My bro told me I should buy Bitcoin, and I bought it with card. Let's say I bought it online, and I just bought it a couple of minutes ago. And I'll just add the transaction, and let's refresh. Hopefully we should have three different statistics. And now it is time to actually use this data and then render it inside the chart. Let's go ahead into the homepage and try to implement that. So here we are using a hard-coded data. So I'll just copy it, or maybe I'll just cut it and put it at the top, and I'll just comment this out so that you could have it as a comment for reference. And I'll just paste it again actually, and I'll say instead of having this as an object, I'll just say this should be a state value, and then I'll wrap it with this function. And for labels, we don't really want to have this hard-coded data, but instead we're gonna have so to say the dynamic value that'll be coming from our database. Now it might not make too much sense for now, but it will. Let's delete the data. Let's delete this background colors and border colors. All of these will be dynamic. So what happens if we have only expense and so only have saving and expense, and if we don't have any investment, then it doesn't make any sense to keep this investment color, right? That's why we delete all of them, and depending on the data that we have, we're going to just update that. And I think, yeah, this should be fine. And instead of percentage, let's say we have $sign for the label. Now, just to make this a bit more readable or formatted, I will put them, paste it at the top, where we'll just have one query at the very top, and then the mutation. So if we try to save this file, now it should crash, right? It's because it really cannot find So let's see. So it's gonna crash because of this chart. We sent the chart data, but for now it doesn't have any data into it. So it is not going to be able to map this data and render anything on the on the client. For this, we're gonna write a use effect. Let's say first initialize it, and this use effect will run whenever the data changes, and this data is coming from the transaction statistics. Then we could say if data dot category statistics. If we have this data, then we'll just do again a couple of things, which I'll just type it first and then explain. And instead of typing, actually, let's copy and paste one by one so that we don't waste too much time. So we had the category statistics in our console, right? We see that. So we got each category and we put them into an array. Now this category array looks like, let's say, expense, saving, and investment. Okay, this is our output for now. And then for the total amounts, I don't know what values we have added. So we're gonna have, let's say, $100 for saving, $200 for that AirPods, which is expense, and then we said $1,000 for Bitcoin, which was the investment. Okay, for now, this is the data that we have. And then we're gonna create the background colors, because if you remember, this is empty for now. So I'll say background colors, and that's gonna be an empty array that will just update. And then we'll have the border colors. Then now it is time to actually for each this category. So I'll say categories dot for each category. We could just put C, and then we're gonna run this if checks, and let's just copy and paste it as well. It is not, there isn't any logic. Let's say this should be category. Okay, if the type is saving, then we're gonna add these colors for the background as well as the border color. Then we're going to do the same thing for the expense and then the investment. Now this makes it dynamic. If in our database, if we don't have any investment, then we're not gonna put this color into that chart. And I'll just preview that once we complete this function. And then let's say lastly, we'll say set, it was the chart data, right? We're gonna take the previous state, then we're gonna return an object where we'll just say labels should be these categories that we have created. Again, it's gonna be expense, saving, investment. Then we're gonna have the data sets, and it is this array that we have in our, let's say, the hard-coded data. So we are basically writing this part where we'll just add the background color, the border color, as well as the data that we are getting from our database. So this data set, we're taking an object where we said we're gonna take the previous data sets and take the first object, and then we're gonna update the data field, which is gonna be the total amounts, and then we're going to update the background color to be this dynamic array, and then the border color. Okay, so we have, is this not defined because we said that this is going to be use state, but we didn't create it. Let's say set chart data. Okay, so we have the value as well as the setter function. And let's save, hopefully this should work, and we just pass this state into our donut chart. If we refresh, and there we go, now it is working as expected. We have our saving, we have our investment, which was $1,000 for that Bitcoin. Then we have the expense. Now the least amount that we have spent for was savings, then the most was investment, and in the middle we had the expense. Now let's say if I delete the expense, in our database we don't have any. Let's refresh. So here we can see now we are not pushing this background color inside the if checks. Now we don't have any expense in our categories, so we don't really add this expense colors to our background colors and border colors. That's how we make it dynamic. And now let's make it in a way that when we delete one of them, that should immediately update this. And could you just solve it, or should I? Okay, I'll just go ahead and solve it. Now, what we'll be doing when we delete it inside the cart, basically we will send another refetch query. Let's say we would like to fetch the get transaction statistics. Let's go ahead and I'll refresh. I'll first add, let's say, AirPods. It was an expense of $200. Now we have added, and again, we're gonna refetch it once we create the transaction. But if I delete that, it should immediately update this part as well. Okay, there we go. Now it deleted from the UI and from the chart. And now when we add it inside the transaction form, we'd like to just refetch this query as well. Let's go into the transaction form. When we create it, we are fetching the get transactions, and we'd like to just fetch this one as well. Now let's refresh, and we're gonna create again, let's say AirPods. It was an investment for my ears, and I'll say $400, and I'll just add a date. There we go. Once we add it, it's been added to here as well. Let's add an expense. I'll just say rent of $800. And then add the transaction. There we go. It's been added here, and then our chart as well. Let's add a bit of salary, which is type of expense, saving. There we go. Now we have the most the most transaction that we have spent is our saving, and the least for the investment, and then in the mid we have the expense. And let's try to delete this one. Everything works as expected. Now let's try to just update a transaction where we have the most spending on the salary. Let's make it the least, where I'll just make it $200. And if I update the transaction, I'll just go back to the home page, but it didn't update on the statistics, right? It updated the the history, but not this one. Let's try to fix it. We're gonna go into the transaction page where we update it. We'll just run a refetch. So refetch queries, I'll just say get transaction and statistics. Let's try to do it as well. I'm just gonna make this saving to be the most value, okay? And it should be the greatest area. Let's go ahead, say that's gonna be 8,000, and then I'll just update it. It says it's been updated. Let's go back. It's been updated on the card, on the history, as well as on the chart data. Okay, I think our application is completed now, but there are a couple of things that we'd like to fix. Let's first start with this user profile pic, and then we'll just take a look at the rest. Inside the homepage now, shrink this use effect. If you want to, you could take this into its own hook as well, but let's keep things easy and not make any complicated. We'd like to fetch one query. Maybe I'll just duplicate this one. I'll say get authenticated user, and then this is data, but we already have one called as data. Let's rename it to be auth user data, and we're gonna import this. For some reason it doesn't give us. Let's say get authenticated user from this query file. Then in our profile, instead of this hard-coded value, we'll say auth user data dot auth user, then the profile picture. And there we go. This is the profile of Jane, and let's log in as John. And this is the profile of John. So it is working as expected. Now what we'd like to do next, I think, is gonna be the relationships. Now in our application, we don't really need to add any relationships. For now it is working, and this is not a advanced application, but just for the sake of teaching and learning, let's go ahead and add it. So we'll go into the backend, and now we'll be able to see how to add relationships and how to use that parent argument. Inside the user resolver, where we said we'll be adding a relation. So that was the to do. Let's delete it. Now we had two types, which is the query and then the mutation. Right at the very top, we have the mutation and then the query. Now we're gonna add our special type, where we'll just say user and then the transactions. This basically reads as get the transactions of the user, and we'll get, let's say this is going to be async function. The first argument was the parent, but we have never used it and it is time to use it. Then we have the args, we can skip it, we're not going to use it inside here. Then we have the context, and maybe we could skip the context. I'm not sure if we'll be using it, so let's delete this as well. I'll just put double underscore, or maybe we'll just not add any of them. Okay, so that was the parent that we got. Let's have a try catch, and then for the catch, let's just quickly, let's say console log. I'll just rename this to be error. That's how I'd like to call it. And I'll say error in user.transaction resolver, and then the error itself. Then we could just throw an error that says just the error message. And then in the try, we'll say const transactions. We would like to fetch the transactions of this user. So transaction dot find, where the user ID, let's say, will be the parent dot underscore ID. Okay, this is not making any sense for now, but it'll make in a second. Let's delete this user's dummy data, and I'll duplicate this one. I'll just call it as transaction, and this should be coming from the transaction model.js file. We have the transactions, and now let's try to send it or return back. So basically we say we would like to fetch the transactions under the user object, and this is possible with the help of parent argument. As your application gets larger and complicated, you'll be using this parent argument more than you think. Let's go into the front end, where we'd like to create a query to fetch it, but we need to also add it into the type defs. So we had under the user, we added the transactions. Inside the user type defs, so here we'll just say we'd like to have transactions, which are gonna be type of transaction. And let's say this should be a nullable value by adding this exclamation point. Let's save this one, and we're gonna go into the queries, where we would like to add, let's say, export const get user and transactions. So let's create a query. I'll say get user and transactions. We're gonna pass the user ID. Then we're gonna call the user query. We're gonna pass the user ID because this is how we are calling it. Let's see inside the queries. Okay, when we fetch a user, we pass the user ID. And then we're gonna open this up. Then you could get the ID field of that user, and then name, then username, then profile picture. But if we didn't add this resolver as well as this this relation under the user type defs, we shouldn't be able to say transactions of this user. But since we have added that relation, now in a one single query, we're able to get the user profile as well as their transactions. Now we had the fields like ID for the transaction, the description, payment type, and all these fields. And this is possible with the help of relationships. Okay, we fetched the user, we got all the fields, and now we are able to go one graph in and get the transactions, which is another type def and another graph basically. Let's try to call this one. If we go under the home page maybe, or let's say inside the cards, we could add another query. I'll just say get transactions, get user and transactions. Okay, we're gonna get a loading and data. Let's say user and transactions. Let's first try to console log it. Let's save, and in our console we should be able to get those fields. In this account we don't have too much transactions, so I'll just go ahead, log in as Jane. And in our terminal now we have user and transactions. Again, it is empty. Let's refresh now. Okay, it looks like we have another error in our resolver. Let's try to see that. So in our user resolver, that should be user ID, but not the user. Sorry about that. That's how we defined it in our transaction model. Let's save. We're gonna refresh. We have user and transaction, and it is still empty. Maybe we have another error. Let's see. So the other thing that we were missing is that we didn't add the variables into this query, because that's how we how we initialize it. But now we need to say the variables where we're gonna add the user ID, and we could pass, let's say, the authenticated user ID. Let's get the authenticated user. Then I'll say data, that should be auth user. And we're going to delete the loading state. Let's say user ID will be auth user and auth user.id. Let's save. Hopefully that should work, and we'll just try to reiterate again what we have done. So we have user and transactions. Just focus on this object. We have a user, and we got the user profile, right? Username, profile picture, name, and this is expected so far. But now we are also getting the transactions array, which is array of objects for each transaction. And so I think you are able to see with only one transaction, you are able to get the user profile as well as the transactions. So we didn't really need to add this in our application because it is relatively small and not larger or complex at all. But as your application grows in GraphQL, you'll be using relationships more than you expected. And then also in our resolvers, we said that we will add another relationship, but I think we could skip it because we don't really need it, and we got the point. If you want to add it, I'll just provide it. So here I'll just delete this to do, and we are under the transaction resolver, right? We have the query and then the mutation. Now we would like to say transaction, and then this is going to be an object where we have the user resolver. Let's say async. We're going to take the parent, and then we'll have the args. We're going to skip it, and actually we don't need to, so let's delete them. Then inside we'll just have again the parent dot underscore ID, which is going to be our user ID. So we could say const user ID, and then we'll have just try catch, and then in the catch let's handle the errors, or maybe I'll just copy and paste the entire try catch. Okay, so in the catch we throw the error, but in the try inside the user model we basically trying to find the user by ID, and that ID is coming from the parent. Now when we write a query for transactions, we were able to get the user for that transaction, and this works as exactly the same that we have done here. Now we need to add this in our type defs as well, where we have the transaction type def, and we set that, let's delete this to do. And for a transaction, we said that we're gonna have the user field. This transaction belongs to this user, and this is for relationship. Then let's go into the queries where we'd like to just add one extra query. And instead of writing, we already have one, right? We are fetching a transaction, but now if we want to, other than these fields, we could say, give us the user field for this transaction. Who created that transaction? So we'll like to get the name, and then the username, then the, let's say, profile picture for this transaction. Let's try to see this in our transaction page. I'll say, okay, I'm sorry if there are too much files open, but basically we'll go into the transaction page, and we got one transaction. Let's try to console log it. So console.log, I'll say transaction, and it is going to be this data that we are fetching. Let's save. We're going to go into this page, open up the console. We have transaction, and again it is undefined, and the reason is inside the transaction resolver. Let's go and open that up. So transaction resolver, we said that we would like to fetch a user from the parent._id, but this parent._id means this is the transaction ID. Okay, so parent is transaction, and parent._id means the transaction of the ID. We cannot find the user with the transaction ID, right? We need to get the user ID. So that should be user ID, and that's gonna work fine. Now, I hope we are getting the point. Whenever we say parent, it is gonna be this one because this is the parent, which is the transaction. Then you'd like to find relation or the users that are associated with this transaction. And in our case, it is just gonna be one user. Now let's save. Hopefully that should work, which I already tested out. Let's refresh. We have a transaction. So we have the amount, category, date, location, description, payment type, and then we have the user, and there we go, with only one request where we get the user, right? I mean, where we get the transaction, then we have the user that is associated with this transaction. And that was the relationship. I hope I made it clear to just explain it. So yeah, that's gonna be it for the relationships. And now also inside the cards, so for each card, we would like to show the profile picture of the authenticated user. Let's go ahead and fix that, where we have the card component for each card, right? We have the authenticated user. So let's just try to pass it. I'll just say the auth user, let's say, and we're just gonna pass the auth user into it. Or maybe just, let's say, auth user, oops, dot auth user. Okay, we just passed the object immediately. Then inside the cart, we're gonna take it. And then we'll just say inside the image, let's see, instead of this hard-coded value, we'll say auth user dot profile picture. Let's save, and there we go. Now all these transactions has been created by Jane, where we could delete the transactions, and that's gonna update our chart. It's gonna update our transaction history, and if we don't have anything, that is going to just delete the history as well as this part. But now we don't want to see this empty area. For this, I'll go into the home page, and we'll just wrap this with some kind of condition. And the condition will be this one, where we'll just say data.category statistics.length is greater than 0. Then we would like to render this part, which is our donut chart. But if it is empty, if it is an empty array, then we're going to skip this and we'll only show the transaction form, and that's going to be the output. If we try to add one, let's say salary, and we could, and now what happens if we just skip one field? It's gonna say error creating transaction. We need to just fill all of them. And let's add this. Here we can see this has been updated immediately, as well as the history. And we could add another one, and it's just gonna work as expected. And yeah, this is gonna be our application. Now let's try to deploy this. And before we try to deploy, I'll just give you some notes into this file where we already have these ones, and I'll just add a little bit of note that I have just copied and pasted from the documentation in case you would like to use it. Here it starts with the Apollo client that we have used in this part, and here are some features, some code examples, and just caching and the packages that we used to be able to make it work. So let's go ahead and first commit this, where we'll just say project completed. And first we need to add all of them. So let's say add to the staging area and project completed. And a project never completes, but let's say tutorial completed. Or maybe I'll just say connected both of the parts, which is the backend and frontend. So I'll commit this one, and then we'd like to go into the backend index.js, and we're just gonna set up this in a way that we could deploy our application. Now we will be using render to deploy our application, so render.com, which we'll visit in a second. So the important thing about this one is that we are going to deploy both the backend and the frontend, so React application and the GraphQL API, under the same domain. And that means we will be able to just run both the backend and client in a domain like, let's say, localhost 4000, which is our backend application. And to be able to do this, we need to just set up this index.js. After all of our routes, which we have only one, which is GraphQL, and we'll just say app.use, we'll say express.static. We're going to use this middleware, and we'll say path, which we need to import from the path module. So let's see, very at the top, we have this. I'll replace it and just put it to here like this. So we'll say express.static path.join, and we're gonna have a, let's say, their name, which is gonna be a variable that we'll create. So at the very top, we'll say const their name path.resolve, and this basically means the root of our application, because we have the package.json that will run a couple of scripts. And under their name, we will say, so we are basically joining them, okay? We are inside the root, we'll go into the front end, then we will go into the dist folder, and I'll explain that in a second. And after this, we'll just say app.use or get any routes other than this GraphQL route that we have. We would like to call this controller request and response, where we would like to just render our React application. So res.send file path.join, let's call this function, where we'll just say their name, and then frontend dist, and I'll just put a comma index.html. So in production, you don't really run this React application as it is, but instead you type npm run build in your command, and once you do that, you'll get a dist folder. It's gonna be inside this front-end folder, and it is the optimized version of your application. So let's say npm run build will build your front-end application, or let's say app, and it will be the optimized version of your application, okay? And we say make that folder to be the static assets, and whenever we hit any route other than the controllers in this route that we have created, we would like to render our React application. And to be able to run that npm run build command, we'll go into the package.json. Here under the scripts where we had the dev and start, we're gonna add another one. Let's say build. We will run this build command in our render.com account. So that's gonna be our remote server. And here we would like to install the packages for our backend, which we could do by typing npm install. This will install the packages for the backend, okay? It is gonna install this node modules folder in our render account. And then we'll say npm install -- prefix front end. So basically we say, now that you have installed the packages for the backend, go into the front end folder and then run this command so that you could get the packages for the front end as well. Then lastly, we'll just say npm run build inside the front end folder, and that's gonna create that dist folder. And now that we have our production ready application, in our render account, we'll just run the npm start command, and that's going to run our index.js file and start our application. And here we could also say node env will be production, and I'll copy this, paste it to dev. We'll say node env will be development, And now we don't really need to deploy this application to be able to test this. So we will go and kill both of these terminals, and I'll just open up a new one, kill the older ones. Inside the root, we will say npm run build. That's going to run this command. It's going to install the packages for the backend, which we already have. Then it's going to install the packages for the front end, which we also already have. And then it's going to run the build. And that's going to create a dist folder, which we don't have. That's why it's going to take a bit time. Here we could see. Now we got the dist folder, and it says your application just optimized, and you have the dist folder. Now it gives us a warning, which it says you could use the code splitting. This is not really too much important for this side project, but if you want to, you could add it. And yeah, that's gonna be it. Okay, so we also have this command called start. Let's say npm start, which is going to start our application under the same domain. We are both gonna have the backend as well as the front end. Let's go into the localhost 4000, which were our backend application, right? But we visit backend, but we still get the React application. Why is this the case? Is because that's how we set it up in our index.js file. We set any route other than GraphQL, we should be able to see the React application. And if we visit /GraphQL, it says you cannot see anything because we said the node.env will be production. Let's delete this part now and kill the terminal and then open that up. So if we refresh, we will be able to see that graphical tool, and we don't want to see that in production. That's why we said node.env will be production. Now I really hope all those make sense because they are not basic concepts. Okay, so if we try to kill our terminal once more, oops, and I'll say npm start. Since we added this node.env to be production, we will not be able to see this in the production, okay? And our application should work as exactly as it before. We could delete transactions, we could add ones, and if we wanted to, we could update, and that would work as well. We could log out, we could log in, and we could sign up. It's just gonna work fine. So I think there is one last thing that we'd like to update. So here, let's see what is going on. Okay, we don't have any errors, that was just previous. And inside the to-dos, so here we said in main.jsx, we would like to update this on production. Now in production, we're not gonna have the localhost, right? So for this, I'm gonna go ahead inside the front end and I'll say .env, and then I'll say vite underscore node env, and here that's gonna be development. And then in main.jsx, to be able to get the environment variables, we say import.meta.env and then vite node env that we have just created. We say if this is equal to development, then our GraphQL URI will be this localhost value. But if this is not the case, that's going to be whatever our domain is and GraphQL behind that. Okay, that's going to be it. Now, hopefully this should be fine to deploy. I hope we didn't forget anything. I'll just try to commit this, where I'll just say git add all, and then I'll just say deployment setup completed, and then commit this one. Now we could kill the terminal, then we'll just try to push this to the GitHub. So I am in my GitHub account, where I'll just create a repository, and I'll just say maybe GraphQL crash course, and then I'll make it public. I'll just say create a repository. That's going to create it, and we already have a Git repo where we would like to just push our changes to this GitHub account. I'll go ahead and say in our terminal, just paste it inside the root. My branch called as master, yours should be main by default, and if it is, don't worry, just press enter and that should push it to our GitHub account. So here on this page, if I refresh, you'll just see, there we go. We have the front end, the back end, and everything that we have created is just here in this repo. We would like to now go into the render.com and then deploy this application. Now go into the render.com. If you don't have an account, create one for free, and then you could deploy applications for free as well. No credit card required. We're gonna say new web service. This is the one that I have deployed. This is the demo application basically. And we'll say add a new web service. We would like to build and deploy from a Git repo. Then this is the repo that I have created 1 minute ago. Let's say connect. And then let's see, we have the master branch. Okay, for the build command, we'll have npm run build. This might be main for you, so don't change it. And so this is the build command that you have created in the package.json. That's going to run it first, then it's going to say npm start for the production ready application. Then we'll say go with the free tier, and we would like to add the environment variables, where I'll just open up the .env file. We had the Mongo URI, and then we're going to just paste it. So here I said Mongo URI, and then I'll put the value, which is all this, and then I'll paste it. Then we need another environment variable, which we called it as session secret, and the value was my secret 123. Let's say create the web service, and hopefully that should work without any errors. That's gonna take a bit time, so let's wait for the logs and we'll get back to the video. So here we can see the deployment has been completed, but it failed. It cannot connect to MongoDB. And to be able to fix this, so this is related to IP address. We didn't allow this server to be able to connect the MongoDB database. For this, go into the dashboard, just open that up in a new tab, and then we'll say settings, where we would like to connect, and copy one of those. I'll just get the first one. This is the IP address of this instance. Okay, so we'll go into our MongoDB account, under the network access, press that button that says add IP address, paste it, and then if you want to, you could add a comment, then just say confirm. That's gonna take a bit time, so once it's been completed, we'll just try to redeploy our application. So it has been completed, it says active. Now let's go into the render dashboard. Here under our projects, I'll just go at the top and I'll just say manual deploy. Deploy the latest commit again, and let's wait for it and let's see if that's gonna work or not. Okay, there we go. Now our application is live and it's been deployed successfully. Let's try to visit this page, and this is our application. I'll try to sign up with, let's say, Bob Doe, and then I'll just put a username and then a password from 1 to 6. I'll say mail and sign up. Hopefully that should work. So we have loading state. Probably there is something wrong with the server, where we might get 500 status code. Let's see. Okay, so it just keeps hanging. I'll just refresh and do it again. So I'll say mail and sign up. So it keeps hanging for some reason. I don't know if this is related to render, but go ahead into your MongoDB account and add another IP address, which should be allow access from anywhere. So 4 zeros, and confirm this. Once this has been activated, we'll just test it out again. Okay, so it says active. Now let's go ahead and test it out. So once I do that, it signed the user up. Let's try to sign up with a different account. I'll say let's say gen do, and then we'll say gen for the password from 1 to 6, and female, sign up. And there we go. Now it is working. Let's try to create a transaction. It is saving, let's say salary. This is the amount, and we'll just put a date. Location could be New York. Let's say add the transaction. It's been added. UI updated. Let's add an expense. Let's say it was an AirPods. We just bought it yesterday. And then add the transaction. There we go. UI updated. We could delete them. We could update them. Let's say it is from this amount, let's say 1000, and update it. Let's go into the home page. There we go. It's been updated both here and not here. Let's refresh. Okay, when we refresh, it's gonna update. And the error for this that I have found online, let's go into the, let's say it was the home page. When we create the transaction, okay, it was the actually when we update the transaction. So it was the transaction page. When we update it, we run both of these queries. Now I'll just provide you a link that other people also had these similar issues where it updates one of the, or it refetches one of the queries, but not the other one. So let's try to visit that GitHub issue. So I copied the link. Now I'll just paste it. And let's try to see. Here we can see they say refetch queries not working when using string array after mutation. Now you could read it. I really read it and see one solution. I saw one solution that someone else answered, and they say just put them into an object, and then under the query, and then okay, so it was this solution where they say run this refetch query and then just put it into here. Let's go ahead inside the transaction page. If you say refetch queries and then say this is going to be a query where that's going to be, let's say we'll just add the get transaction statistics. That should be inside an object that they have shown inside that GitHub issue. Okay, now this should be working. Just try to add a git commit. So I'll save, and then we'll say git add all git commit -m. So refetch queries fixed, and let's say git push. Whenever you add a new git push, the render will deploy your application again. So here, if we go into our dashboard, we'll just see that they are trying to deploy this application because there is a new commit in our GitHub repo. Let's wait for it, and then we'll just test it out one last time. So this has just been deployed. Let's test it out for one last time. I'll refresh our application. And then we have this value, 1000 for the saving. Let's go and update this. To this value, let's update. It should both update in the cart as well as here, and there we go. So everything is working fine, and I just really wanted to show you every single edge case, even though even this refetch queries problem or the error as well. So here I even just put the comment of the GitHub issue, and I said refetch query is not working, and here is how we fixed it from the GitHub issues. And with this, we have completed our entire application where we just built the front end and back end, and then we deployed it. Everything works as expected. We just have one possible issue, and let's try to fix it. Now, this is the website that we have deployed. And at this point, I'll just pause the video about 15 to 20 minutes, and then I'll come back. And the reason is when you don't visit your application in like 15 to 20 minutes, it's going to be inactive. And when you send another request, that's going to take a really long time to load. So as I said, I'll just pause the video about 15 minutes, and then I'll just come back. Okay, so it's after 15 minutes. Now let's try to visit our application where it's just going to take a really long time to load. There we could see from the navigation, it just loads and loads, and that takes about 1 minute to load our application, and that's what renders as in their dashboard. They say if you use the free plan, that's going to be the case, it's going to be inactive. And to be able to solve this, where we just want to, whenever we visit our application, we just want to immediately see that in our browser. And for this, we'll be using something called cron jobs. Here we can see it just loads and loads, and let's see when that's going to give us a response back. Now render finally gave us a response back, and here we can see this is our application. Now if we just copy this link and close this, and if we visit, now it's immediately gonna give us a response back because it is active now. But if we wait about 15 minutes, 20 minutes, and if we don't visit this app at all, and it's gonna be the same situation where it's just gonna take really long time to load. And as we said, to be able to solve this, we'll be using cron jobs. Let's save this file, and I think we could close all of them. And inside the backend, we'll just create this file called cron.js. And we have installed a package for this at the beginning of the tutorial. Let's see if we have it. So cron, okay, we didn't actually install it. Let's see from the copy paste list if I have it or not. Yeah, we don't really have it. I forgot to provide that. So let's try to install it. In our backend, we'll say npm install the cron package. So first I'll just give you explanation of the cron, and then we'll just try to just implement it. So I will just copy and paste my notes, and then I'll just put it at the bottom of this file. So cron job explanation. Cron jobs are basically scheduled tasks that run periodically at fixed intervals or specific times. And in our case, we would like to just send one request. Let's say send one request, which could be get request, for every 14 minutes, let's say. And we'll be doing this just to keep the server active so that whenever we send a request in our browser, we'd like to just get a response back immediately. And to be able to schedule these cron jobs, you define a schedule using a cron expression, which consists of 5 fields representing the, I'll put the comment, the minute, the hour, day of the month, and then day of the week. Now I have a couple of different examples and their explanations, so I'll just put it here as well. So this basically means every 14 minutes, send a request or just do a job, which is cron job, okay? At every 14 minutes, this is our interval, we'll like to do something. And then at midnight on every Sunday, we'll like to again just do something. And this is going to be that cron expression. And with the help of it, we could do schedule tasks. Feel free to check out these examples and their explanations. Now at first, it might not make too much sense, but it is pretty basic concepts. And we'll be using this one to send a get request on every 14 minutes to keep our server up and running and in the active state. So we'll say import the cron from our package. This is what we have installed, and then we'd like to get the HTTPS to be able to send a request from HTTPS package. This is built-in node package. Then we'll say const our backend URL. I'll just say URL, and let's get this entire URL and then just paste it. That should be a string, and I'll delete the login part where we could just send a request to the homepage. That's basically the same thing, but let's say const job and then new cron job, where we'll just say on every 14 minutes run this function. And let's open this up. We'll say https .get method, and we'll send a get method to our URL, and then we're gonna get a response back. This is the callback. We'll say if res.status code is 200, that means it is okay, it was successful. We'll just say console.log request sent successfully, and in the else case, request failed. and we could say res.statuscode. And we could chain another method. Let's say on the errors, we could just console log the error. And if you want to, for debugging purposes, let's say error, while sending request. And that's basically it. We'll just export this. Export default the job. On every 14 minutes, we send a GET request to our backend URL, or basically our application that is running on render. And then inside the index.js, this is where our application runs. We're gonna go ahead and let's say import the job from, we got an auto accept from Cron.js. And after these configurations, we could say job.start. And that's going to be it for the cron jobs. And to be able to see this in action, we'd like to deploy our application once more, which will be the help of Git. So we'll say add all of them to this staging area. Let's add all of them. And then let's say cron.js added. We're going to commit this and let's say sync changes. That's going to push this to our GitHub account, to the repo basically. Okay, it's been pushed. Let's see that in action. So here on render it says deploying, where this is the status, and then we have cron.js added just now. And after this, whenever you visit our application, we are not going to have that loading state. It is immediately give us a response back, just like this, because now we have the cron jobs and that scheduled tasks that will send the GET request for us every 14 minutes. And I think that's gonna be it for this entire project. I hope you were able to follow along until here. And if you like this content, let me know in the comments. Thanks for watching, and I'll see you in the next one.